I think it's split because there's an alley. Different buildings.
That's basically
But same block. Same block. I have. It was actually interested. I've been to Donkey's place. You can see like is it the micro units? One.
All right, we're gonna get started. I just put a link to the YouTube stream in your GD72 channel if you're gonna be using that. Otherwise, I'll just be on Discord as usual. How's everyone? Sorry. Oh, I can hear myself echoing. Okay, we're good. How's everyone doing? Doing all right. Weeks left in the term. So today I have kind of a couple options. My plan was to do some visual effects stuff with you. We're gonna do some like explosions and fire and that kind of stuff. The other option we can do, we're gonna end up doing both regardless, one this week, one next week, but I've had a lot of questions about camera setup and stuff for your team project. So we could alternatively do camera stuff today. I kind of want to get some feedback from your class and figure out which you'd rather do right now.
Explosion.
Explosion. Here more votes for camera right now. Okay, you know what? Let's make this super official. I'm gonna put 2 messages in your GD72 channel. Yeah.
Oh, explosion. Didn't we do camera kind of last one? The photo was cast.
Okay, so react to my message with the fire for the VFX stuff or the camera for camera stuff.
Say it. Like camera is like that. Like camera shaking. We didn't do that. What do you mean by camera? Like setting up a cinema machine?
Yeah.
Oh, cinema machine for sure. Yeah. This is too much power. Did you make the dog one? The dog one?
I did make that one, yes.
Beautiful. I love that dog.
That's Chris's like hostage emoji.
The dog mom. The dog. Oh. Lost my.
Okay, so our winner right now is camera work with Among Us as a close second. So we'll do Cinema Machine stuff today to take a look at camera setup. And then next week we'll do our VFX stuff.
Among Us is in first.
People want Among Us. Let's make Among Us. Among Us among them. Among Us among Carter.
Okay, so to get started, we're going to open up Unity Hub and open up our project again. Years ago, there was this like string of towns that realized they could do like public forums and voting to name stuff. And there were just all these really dumb results of like a town like officially naming their new like search and rescue craft, like Bodie McBoatface and stuff like that.
Oh yeah.
And the funny flavors.
Gushing grandpa.
Okay, Unity Hub, are you opening? This PC is so slow today. There we go.
It's not general.
Yeah, gifs and memes are allowed outside general. Okay, I think my Unity Hub crashed. This is a good start.
My Unity moment.
Very good start.
My Unity. As you can say, it's
Whoa. What?
someone is someone that I try like on down. The internet crashes when crashes.
Yeah, sure seems to be the case. Oh my god, Unity Hub just opened. Please.
Poker face.
Even running? Okay, there we go. There we go, finally.
Yep, my one.
Oh, you listening to poker face? Fire song, bro.
I am.
Double song choice.
The lyrics are actually about poker face. Poker face. Good. I didn't know that. It is. The reason I really yes poker. Because it is oh, is it down?
No me lo puedo creer.
Yeah.
Here's it's down.
What's down?
Or at least for Mr. Sergio here.
What's down?
Unity.
Just says couldn't connect to server.
Are you able to get Unity open? Is anyone having trouble getting Unity open? Do you still play and everything?
I like
Not a big fan of the visual scripting options in Unity.
oldest able to be.
Okay, let's quiet down and get on track here.
The movie?
All right, so today we're going to be taking a look primarily at a single plugin for Unity called Cinemachine. If you look it up, they have some pretty good documentation examples of it. This started as a paid asset a studio produced, and it got popular enough that Unity basically just bought it. And it's added to Unity for free now. And oh my god, this PC is slow.
Somebody else find it.
Double check.
I think it's not just you. Ours is pretty slow.
Yeah.
The whole internet is slow right now.
Jeez.
Uh-oh.
Yeah, no, it's just me on here.
Is someone unplugging the router every time you go to the bus?
Could be.
Someone just pranking Quinn.
There we go. All right. So Cinemachine is a really cool plugin. It started off more specifically for cinematic type stuff, but has sort of adapted to work quite well for actual gameplay type functionality as well. It has a lot of really cool stuff. Does anyone have any sort of like film background? Yeah.
What?
Does foundation class count?
Yeah, it does. So some of the stuff you'll learn about film transfers over a little bit in terms of how they like set up shots and focus on certain areas. And we can apply that to cinematic cameras, gameplay cameras, 2D, 3D stuff, all sorts of cool applications within Unity. So we're going to run through a bunch of kind of standard setups in Unity. And we'll take a look at what we can do with Cinemachine, how the plugin works, what additional stuff we can kind of layer on top, all these kinds of things. So let's go in, and to get started, let's make a really, really simple example. Inside our scenes folder is one called 2D Platformer. It doesn't get a whole lot more simple than this. So the way all these scenes are set up is it has a character and a Cinemachine camera tracking that character already. What we're going to do is we're going to go through most of them, and we're basically going to break that. We're going to remove the Cinemachine camera, and we'll add our own. So in this scene, we can hit play just to get started. We can run around. Here's our 2D sprite guy, and he moves around. The camera here, you'll notice I've made a few adjustments. So when I go left and right, the camera doesn't immediately snap to move with my character. I have a little bit of kind of leeway back and forth, and even a little bit going vertically as well. So you can add all sorts of kind of cool functionality to kind of smooth out the way the camera works just using Cinemachine itself. what we're going to do to get started, I'm hoping everyone's got the scene open already, the 2D platformer. Everyone was able to find it? Cool. Okay. So inside of the section here in our hierarchy that says characters, we find this thing called the 2D platformer player container. I called the player container because it actually has two things inside of it. It has the player itself, who is the little sprite guy right here. And then it also has this player cam. You'll see the player cam object is a Cinemachine virtual camera. What we're going to do is we'll leave this one in place, but we're going to set up our own. So what I'm going to do to turn this one off is I'm going to select it, and then over in the inspector here in the top left, you're going to see a little checkbox. We're going to go and just disable this camera. We're going to turn it off. You'll see it grayed out in the hierarchy here, which means it's disabled. It's not doing anything. If I hit play, I can run around, but my camera doesn't move. So what's interesting about that is we've turned off the Cinemachine camera, but we can still see stuff. That's kind of the cool system that Cinemachine has in place. So we only have one camera in our scene that's actually rendering things, but Cinemachine creates what we call virtual cameras. They're like placeholder positions that might have some logic applied to them. And then based on whatever settings we use in Cinemachine, we can switch between those virtual cameras to change our kind of camera state. Good example I like of this is, let's see if I can even watch the video. But if we look up Gears of War 5 gameplay, oh, let's also add no commentary because I don't need to hear anymore. Come on, internet. Let's skip forward a bit here. Here we go. This is a good example of having a lot of different kind of camera shots in one scene, even though they're probably just moving a single camera around. So they've got a whole cinematic sequence where they're cutting back and forth between different cameras. You also notice they've got some things going where there's some noise added to the camera. The actual helicopter itself probably isn't moving a whole lot, but the camera's kind of shaking to mimic the effect of that helicopter moving around them. Once your players are ready to go, you grab onto a rope and you start like rappelling down into this little ravine area here. You can see it switch over to another camera that's now controllable by the player. But it's not like your typical third-person shooter camera. It's kind of tilted down. You can look around a little bit. But we don't have a HUD or anything right now. So we have kind of our cinematic state, and then we switch over to this kind of rappelling follow cam state. Once he hits the ground, you'll notice the camera switch again into more of a standard like third-person view. Kind of zooms in a little bit more. And moves up. We don't really need to see his lower body. And we've got our standard kind of follow view. Once he starts moving around, add a little bit. Oh, here we go. Here's another state. So he goes into his kind of sprint mode. I don't know why characters in Gears of War sprint like 10% faster than they walk, but he's moving along and it switches into that kind of like lower camera following the character. We can see more of his legs and we get kind of more of a camera shake effect. As you keep going through different kind of gameplay moments, it'll switch again and again. They have a lot of different cameras set up. And they're all there to kind of highlight animations, gameplay moments, focus the player's attention. He eventually goes up to like a little quick time event. Where is that? Oh yeah, here's another good example. Switching into like the aiming mode. So you hold down your aim button and the camera zooms in over the player's shoulder into an aim position. Now, the cool thing about Cinemachine with these cameras is you can set all these cameras up doing what they need to do independently, and then based on some other logic to switch between them. So we don't need to worry about moving one camera from position to position wherever it needs to be. We can just kind of set them up and let them go, and the camera will move to where it needs to be in the correct position. And Cinemachine is set up to kind of interpolate and move between those points smoothly, so we don't have kind of awkward camera cuts. So to set up our kind of simple follow cam for our 2D game here, what we're going to do is we're just going to right click in the scene, and we're going to go down to the section that says Cinemachine. You'll notice there's a lot of different options here. 2D cameras are pretty straightforward. It's what we're going to be using here for 2D stuff. The standard kind of camera you'll use for a lot of generic stuff is this one down at the bottom, just called virtual camera. But we have some other cool stuff in here. Target group cameras are really cool. They are for either showing your player and another object on screen at the same time, or a really good example is you're playing a game like Overcooked and you want to make sure that your camera shows all 4 players on the screen simultaneously, but you want it to kind of zoom in when you get close. They do the same thing in, for instance, like Smash Bros. You're playing like stock mode, you've got like the last 2 players left alive, they get really close together, the camera's going to zoom in. So this target group camera can take care of that logic for us to make sure that our camera's always got those characters in view, but is moving to show them all at the same time. There's also some things like state-driven cameras are kind of interesting. You can tie a state-driven camera system into the animations the player is actually using. So as you enter different animations, good example there would be the character walking around, then sprinting, then shooting. You can tie different cameras to those animations to automatically swap the cameras around based on those states. They have things like the free look camera is good for first person type setups, or even third person systems as well. They also have some cool stuff with dolly tracks and carts, so you can have a camera moving along a track automatically. Or if you want to do a say 2.5D side scroller but have the camera move around a little bit more on a track, you can have the camera follow the player but stuck to a track. They've got a few different things for mixing different camera states together. The blend list, clear shot, and mixing cameras are sometimes useful. They're a little bit wonky to play with, but maybe we have enough time we can take a look at those and some more complex camera blending. For now, what we're going to do is we're just going to right click and go Cinemachine, and we're going to create a new 2D camera. Now, you'll notice it adds a new game object to the scene. One thing that it kind of does automatically for you that you won't notice is while it's added this object to the scene, if we go to the camera section and look at your main camera 2D, this prefab, you notice it has this thing called a Cinemachine brain component. So these things work together. You can have as many Cinemachine virtual cameras as you want in your scene. You always have one camera with one Cinemachine brain. The brain will look at all those other Cinemachine virtual cameras and figure out where our main camera is supposed to be at the moment. So it kind of controls the whole system. Luckily, Cinemachine's kind of smart. When we right click and add a new Cinemachine camera, if we don't have this brain component on our camera yet, it automatically adds it for us. So usually it's a sort of fire and forget. You can also see it adds the Cinemachine logo in our hierarchy here beside the main camera. Now, out of the box, we've added a new Cinemachine 2D camera. It's sitting right here. You notice it's actually kind of at an angle, so our game's going to look a little bit weird. If we hit play, again, it's not doing anything. We haven't configured it and told it what to do, so our character can kind of just move around independently. The two really important things to look at when you first add a new virtual camera, at least one that's going to be following stuff around, is these two fields here. There's a field called follow and a field called look at. In a lot of games, these are the same thing you're going to be plugging in here. In some games, they're different. So the follow is whatever our camera is going to be physically following in space. The look at is the thing that our camera is going to be looking at. So when it comes to a third-person game or a 2D game like this, both of those are going to be plugged into the same thing. They're going to be just looking at our player. It gets a little bit tricky when we're using something like a camera system that's on rails. We'll have our camera following like a cart that's on a track, but the look at will be the player. You could, yeah.
What about a lock-on system?
Lock-on system, so that's interesting too. So for that kind of system, what I would probably do is, sounds a little bit weird, but have two different Cinemachine virtual cameras and kind of blend them a little bit. So you can have one that's looking at your player and then one that's looking at the target. You can kind of mix them together. Alternatively, you could try a target group. There's a few different ways of doing those lock-on systems. Or you could even try, it might get a little bit wonky, but you could try just following your player and looking at your target. That could also work. There's a few different options for that. For our system today, what we're going to do is we're going to plug our player into both the follow and the look at. So I'm going to drag my player right from here out of the hierarchy and plug it into the follow field and the look at field. From here, if we hit play again, now that we've plugged in the follow and look at, our camera's going to move along with our player.
Mine's like weirdly like cutting out when I move with it.
Cutting out. Let's see.
Yeah, it's like flickering. So if I move. It's interesting. Could it be the alignment of my blue?
Everything post processing. You hit play again.
Oh.
It's very strange. Did you play around with the global volume and add a lot of motion mode?
No, let's see it.
You go to
There's no way.
No, you do.
I'll go look at the app.
I think that has something to do with some of the post processing you said.
Is it possibly because of like right click and probably
Shouldn't be, no, it's going to control your camera.
right.
Very weird. Let me try something.
After
Oh yeah, these are the motion.
how did I turn it off?
Yeah, these are motion before.
Did I actually do it?
It was probably when you were playing around with it. Yes.
Okay.
Yeah. Okay. So we have our camera following our player around, but we want to be able to tune things a little bit better. Right now, our camera is basically hard locked to our character, which as we're running through a platformer doesn't feel great. Like as soon as we jump, the camera's moving with us. In most platformers, unless you're like going from one platform to another, the camera usually doesn't kind of snap and follow the player immediately. A really good video for this, actually, dig this up really fast, is someone did a Super Mario camera breakdown. Yeah, here we go. Have you seen this video? Yeah. So it's an interesting kind of look at the way the camera systems work in Mario. Good example is we get further. Oh yeah, this is a cool example. So they kind of lock the camera to the height of the floor you're on. So you'll notice when he jumps, the camera doesn't move. As soon as he lands on one of these platforms though, it moves up. So they kind of have the camera moving left and right with Mario, but vertically it just matches the height of the floor you're standing on, which is kind of cool. So it makes for like a very stable vertical movement, so you're not moving the camera up and down a lot, because this jump height is insane. If you look at it compared to most characters, like he jumps like 4 times his height. And when you get to water, it gets really weird with all sorts of different states. He even shows, if you watch this full video, entering and exiting the water, he kind of breaks the camera so it stops following Mario properly. There's a lot of weird logic going on with the water, but depending on where you are and what you're doing in the game, they have a lot of different camera states going on. So we can create sort of a generic system to allow for a little bit of kind of movement without our camera kind of hard locking to our character. So the way we customize how Cinema Machine works primarily is down here in this section called the body and the aim. Now, right now in a 2D game, our aim, we probably want to leave it on this setting. We're just going to leave it set to do nothing. And the body, if we open this up by clicking on the word body, we'll see the options for this thing called a framing transposer, which basically tries to frame the camera around our player so we can see what's going on. If we go and actually click on the game view tab with our Cinemachine virtual camera selected, you'll even see some guides that help us let us know what Cinemachine is doing. So while we're here, I want to correct something before we start tuning a lot of values. Up here in the transform section, you can see we have a rotation on X and Z, which is doing some weird stuff. We don't normally do this in a 2D game. So I'm going to change my rotation here, my X, Y, and Z just to 0, just to make sure that my camera is exactly where I want it to be. No weird rotations. The other thing you'll notice is with our camera, we're currently rendering in orthographic mode. Does anyone know what the difference is between orthographic cameras and perspective cameras?
There's no depth in orthographic.
Yes, there's no depth. So it doesn't matter how far away we are, everything's going to kind of look the same, which is what we want for 2D stuff. Some games like Octopath Traveler that we've talked about before kind of mix those systems together. They do use a perspective camera with 2D sprites, which can be cool, but for a straight 2D game, we just do orthographic. But the thing to keep in mind there is when it comes to an orthographic system, right now our camera distance is set to like 10 or 10 meters away from the player. That doesn't really matter. If we move further or closer to the character, he doesn't really look any different. If you want to zoom in and out, there's an option here that says lens ortho size. If we change this, change the size of the orthographic camera, we can use that to zoom in and out. So unlike most camera systems where moving the camera closer will make everything bigger, we just have to stick to using this ortho size here. I'll go to maybe 8. Okay, so back to our framing transposer here, we can configure a lot of interesting stuff that can change how our camera behaves. Kind of starting from the top down, we look at this tracked object offset, we can adjust these X, Y, and Z values to control where the camera actually looks in regards to our player. So for instance, right now it's pointing at the player's feet with a Y value at 0. If I turn it up to like 1, I'm going to point more in the center of the character. So we're going to center the camera kind of on the character's torso rather than staring at their feet. Depending on what you want to do for your camera that might work, I think for sort of a 2D platformer like this, I'm probably going to leave it default and just say that we will actually look at our character's feet because that's kind of the most important part of our game is where our character's landing on our platforms. Below that are some options for look-ahead settings. So the look-ahead system, if we go and say turn up the look-ahead time, I'll do it quite drastic, up to like 0.5. Rather than moving right when my player moves and following the player, you notice that little target dot actually goes in front of the player. What it does, what it does is it moves the camera ahead of where the player is moving. So if we're adding a lot of easing to our camera, we can kind of counteract it a little bit and also give our player a little bit more lead time on where they're going so they can kind of gauge where they're heading to their level faster. Even as they move quicker and quicker, we can see more of the level ahead of them. So you'll see this in a lot of like fast moving platformer games, stuff like Sonic. The faster you move, they'll kind of push the camera out so you can actually see where you're going. Now, one option you might want to turn on while you're doing that is this look ahead, ignore Y. So you'll notice if I jump, the camera actually predicts my vertical height up and down, which does some very weird stuff to the camera. So I'm going to turn on ignore Y. Now when I jump, it doesn't really care. The next value is our damping settings. So damping controls the easing of the camera. The higher we have our damping value, basically the slower the camera is to catch up to our player. We want to make a really annoying game. I'm going to crank these all the way up to 20. and start running.
Oh my.
And I'm gonna have to wait forever for the camera to catch up to me. If you want the camera to be a lot snappier and follow the player quicker, you can lower it below 1. Say I change it to 0.1 across all 3. You can see the camera is much more snappy. Depending on the type of game you're making, you might have to tune this quite a bit to get the right feel. For 2D platformers like this, I think the default damping value of 1 actually feels pretty good. Okay, next up we have the screen X and Y. So these two sliders we can use to actually move the camera away from the character. So if you want the camera more near the bottom of the screen, we can turn up the Y to like 0.8. Now it's going to track our player down at the bottom. These I don't use a whole lot outside of like 2D platformer type games. Most games we kind of just leave things centered in the middle, but for 2D stuff it can be kind of nice to lift that camera up so we're not just staring at a whole bunch of empty space below our character. You can notice below the screen X and Y, we have our camera distance value, but again, since we're in orthographic mode, that doesn't really do anything. Zooming in and out, we don't even notice the difference. But the thing below that, the dead zone, is pretty handy. This is how we can set up the system to have our camera kind of lag behind a little bit. If we're making small adjustments left and right, we don't have the camera twitching around. We can go in and start to turn up these dead zone values. Now you notice if I just adjust one of them, not a whole lot happens. You can see those blue lines kind of open up. But it's not until I set both of these above 0, you'll start to see a little area form around the character. I'm going to do something like this, maybe a little square around the character. What this is going to do is when I jump and move around, it's going to have a little box where I can kind of move without the camera moving a lot. So the player's just sitting there, just kind of hitting buttons back and forth. We're not going to have the camera snapping around left and right really quick. Once we start moving, the camera's still pretty responsive. Below that are the controls for this weird blue area we see here, which is the soft zone. So basically, the way the system works is you'll notice we can actually end up kind of outside. This little yellow tracking dot is kind of outside this box, and it's inside the blue area. While that's inside the blue area here, the camera's going to start moving. But it's always going to be kind of slowly interpolating to try and keep that within the blue area. The red area basically says guaranteed that yellow dot is never going to leave that area, so our character won't fall completely out of frame. Now, the way we've adjusted our screen X and Y a bit, our soft zone's gotten kind of weird. This blue area is off the screen, so if we fall, the character can actually move off the screen. If we want to adjust this, we can make changes to both our soft zone width and height, and then we can change this bias X and Y to create sort of our guaranteed rendering space for our character. So if I want my character to never fall off the screen, I could set up an area kind of like this. Round the values a little bit. Something like that. Whoop, so even if I fall off the screen, my camera's going to keep tracking me. Same thing. I can't really... Actually, you know what? I can change my character to jump real high. So if I jump crazy high all of a sudden, let's go jump height 2.25. Let's go up to 50. If I jump very high, it'll do the same thing to keep my character on the screen. Wow, that one's very high. I'll copy and paste the settings I've got in my scene right now into your GD72 chat if you want to reference them. Another interesting thing that Cinemachine does for tuning that allows for some live tuning is you'll notice this checkbox up at the top that says save during play. So unlike most components in Unity, you can actually set this one up. So when you make changes to the play mode settings of the camera, it basically saves them and then loads them back onto the game object when you stop playing. So if you turn save during play on and then run around, you can kind of, whoops, let me fix my character here. You can fine tune your camera's behavior to get it working exactly the way you want without having to worry about like writing down or copying and pasting all the values. You can make kind of live edits to this. So if I wanted to change maybe my look ahead time, lower it a little bit and maybe add a little bit of smoothing to it. When I stop playing, you notice that those changes I've made, those values, are still applied to the camera. I'm a little bit hesitant to use that sometimes since it kind of goes against a lot of the typical play mode behavior in Unity. If you leave it on and you're messing with stuff just to experiment and forget you have it turned on, it also means all those settings are getting automatically reapplied when you stop, which isn't great. Sometimes it's nice to have the luxury of being able to play, mess with a bunch of settings, and then stop and just have everything reset. So if you do use the save during play option, make sure that you are aware you've got it on. And I'd recommend only turning it on when you need it and then turn it back off again. Okay. Now, Cinemachine has some other features. They have little extensions you can add to the cameras to add additional functionality. But I think we're probably going to demonstrate those with other cameras because they make more sense, most of them at least in 3D. Just to show how we can do kind of similar behaviors in different scenes though, let's go and we'll save the scene and let's hop over to the 3D, no wait, let's go to the 2.5D platformer. So this uses a similar camera setup, but you'll notice this one isn't orthographic, it's perspective. We're using 3D art, but the gameplay itself is 2D. We're basically playing Mario just with 3D assets, which is kind of how the modern Mario and Donkey Kong games are made. So we're going to use a Cinemachine camera to set this scene up as well. Just a reminder, I'm in the 2.5D platformer scene right now. And we can create a very similar camera setup, but with a few changes here. So just like the last scene, in order to get our camera turned on, oh, actually, you know what? Let's skip a step and I'll show you some other Cinemachine functionality. So if we look at this player camera in here, the one that's currently in, you can see I've got some configuration on it, but it says priority 10. So this is the kind of simplest low-level way Cinemachine has of determining which camera should be currently active. It uses this priority system. So we can have as many Cinemachine cameras we want active in our scene. If we just change their priority values, that controls which one is turned on. So we'll leave this camera on for a second. In my hierarchy, I'm going to add a new camera. I'm just going to right click and go Cinemachine, and I'll make a standard virtual camera. I'm not going to make a 2D one. Now, we can swap back and forth between the cameras here by changing the priority on the camera I just added. You'll notice when I go to the other camera had a priority of 10 by default. If I change this to 9, the status switches to standby and the previous camera is in charge. If I change the priority to 1 over, if I go to 11, this camera is now in charge and I can see the status here says live. So through code or other means, we can just change the priorities in our cameras and it flips back and forth. Now, in the editor, it looks basically instantaneous. If I do this while the game is playing, we'll actually transition. Oh, and I'm changing field of view here, which looks very weird. That's trippy. I like that.
So say like you wanted to start off the game like from the main menu, then it pans down to the game. You could just change priority camera.
Yeah, that's it. And it'll just animate it all for you.
Hell
Yeah. A lot of teams actually do that for their main menus. So when they open up different screens in their menu, they'll just up the priority on whichever camera's attached to that menu. And they can have like a nice dynamic system where the camera moves around a 3D scene based on which menu they're on.
That's sick.
Okay, so in order for our Cinemachine camera to be in charge, the one we're tuning right now, I'm going to set the priority to 20 just kind of arbitrarily because it's higher than 10. And that means our camera is in charge. Now, for a 2.5D game like this, we're going to set up our camera to be pretty similar, other than we're going to be in perspective mode. To hook it up again, I'm going to drag my player and put it into both the follow and the look at on my new camera. Now, you'll notice some weirdness here. There's a couple issues with it. If we hit play and run around, oh, yeah, that is a big issue. Forgot to mention that one. Right now, our camera, the default mode, is this lock to target with world up. And what it's trying to do is position the camera behind the player, but the camera's rotating and it's causing all sorts of weirdness. So we're going to change in the body here. We're going to change this mode to the same one we used in the previous scene. Instead of using a transposer, you can see this drop down right here. I'm going to change this transposer to the framing transposer mode. So click on the word transposer and select framing transposer. Then we've got our camera, but there's still some very weird stuff going on. Whoop. You'll notice that right now, our camera has our body turned on. This one we created it also came with a composer option for the aim. So it's trying to follow our character, but it's also aiming the camera to point at them, which is very weird. We probably want the camera to have a mostly fixed angle in a game like this, other than a few moments where we kind of do cutscenes or change it for other reasons. So what I'm going to do is change this option down here where it says aim, so currently set to composer. I'm going to change this one to do nothing. So we're going to have a framing transposer to follow our character. But our aim is going to be set to do nothing. So we're getting a similar kind of behavior we had in the other scene. But one thing we always encourage for 2.5D platformers like this is experimenting with the field of view and your height, your distance, the angle of your camera to get the look you want. You'll notice one issue we have, especially if we start to lower our camera distance here and zoom in. Look at the jumps on the side of the screen. So when I'm here, we can see a whole bunch of the side of this block because of the perspective. We're at currently 60 degrees for our field of view. When I get closer, it lines up more, but it's still kind of hard to judge distance. Because our camera is also coming directly on from the side of our character, I can see the corner here, but the actual edge I'm going to fall off is kind of going this way. So it's pretty easy for me to kind of fall off the edge of the platform without realizing I'm not actually seeing where it's ending, which is kind of weird. So we can make a couple changes to improve this. The first thing we strongly recommend you do with 2.5D stuff is lower your field of view considerably. So I don't want to make this fully orthographic. I still want to have a perspective look to it because we've got the, our nice 3D art we've made for our game. But the 60-degree field of view is way too high. So I'm going to take this lens vertical FOV value right here, and I'm going to start dropping it down. And I'm going to take it all the way down to somewhere between like 20 and 30 degrees. Now that kind of zooms me in, but it also sort of flattens the look of the screen. We're sort of getting the effect here, instead of like being up close to someone with a camera, you got one of those like really creepy paparazzi, like super high zoom lenses, and we're really far away from the target. It kind of flattens the whole scene out. To counteract this, because obviously this platform is going to be a nightmare to play, we can start adjusting the camera distance down here and bring it out to zoom back out again. You can still tune it to have the character be the exact same size on the screen to have everything match up, but the whole scene's going to be flatter and it's going to be easier to judge kind of distance and your jumps without having a really, really kind of high perspective look of the scene. So when we've got the perspective, just for jumping, if I change this back to 60 again, zoom in a bit, actually I'll zoom in. You can see here on my screen, see the perspective here on the edge of the screen kind of warps a lot. So it's really hard to judge like jumps. I can see the edge here, but it's kind of hard to judge exactly where I'm going to be landing on that edge. Same thing when I'm leaving here. So it just makes it a little bit harder to play. Yeah. It also means when you have things like props or enemies coming from the sides of the screen, you're going to see the front of them a lot, which is probably not where you really focused a lot of your art. We still want to see a bit of that, but find somewhere kind of in the middle between orthographic and perspective. So for my settings here, I'm going to do a vertical FOV of 20 with a camera distance of 25. That looks pretty good. The other thing we can do, since we have a 3D character in a 3D world, we can also play around with the rotation of the camera. So right now, I have it set to the aim is do nothing, which actually allows us to manually control the angle of our camera just using our transform component. So if I want to go and get more of a little bit of a top-down look so I can actually see the surface I'm standing on, I can adjust the X value of my camera to rotate it up. We usually want to do like somewhere between like 10 and 30 degrees there. You go kind of all the way down like this, you have more of a like top-down kind of view, which you could do as well. But for a platformer, it looks kind of silly. So I'm going to do 15 degrees. Cool. Now, we could tune a lot of the same settings on this camera. We could go through and set up our dead zone and all that kind of stuff. Those settings are going to be exactly like the 2D example we did already. And I have quite a bit I want to cover today. So what we'll do is we'll take a break. We'll start again at 2:05 when we get back. We'll start to take a look at more typical kind of 3D cameras and work our way up all the way to like a third-person follow. Yes?
Are you gonna by chance show us a couple isometric cameras?
Yeah, that's what we're going to do next. Yeah. Yeah, next up will be an isometric, like top-down view. Okay, so we'll take a break. We'll start again at 2:05. Yeah.
So our group for next term we decide to make a top-down shooter, or not top-down shooter, but
Yeah.
isometric view.
Yeah.
And
we're also thinking about like how using the wave system like to spawn the enemies and how hard do you think like to make it like make the difficulty dynamic based on how strong the player is?
So like if the player's doing well, you're gonna increase the number of enemies you're spawning, or
Not like doing well, but like there might be have upgrades for the player to pick up. Like you might be like stronger, like you might move faster, but things like that.
Yeah.
How can you like? Is it hard to implement like a dynamic difficulty system?
it kind of depends how you want to do it. My recommendation for that would probably be just spawning more enemies to make it kind of more challenging, which wouldn't be a huge issue. If you're spawning them in waves, you could just add an extra 1 or 2 enemies to the waves, or you could lower the time in between waves. There's a few different ways of doing that, but yeah, that is possible.
So we also thinking about like have 2 upgrades for the player because the only 5 minutes expense, right?
Yeah.
So you know, we kind of like get like it started with like we probably want like more than 1 type of enemies. So it's like 2 types of enemies. Like you start with just normal weapon, and then you kind of kill some of the enemies, and then once like you encounter like more difficult enemies, like you might like feel like hard to kill them, and now like it's probably the time to give player the upgrades, and then once they like get the upgrades and learn the upgrades, like practice upgrade, like you know, like we can introduce a second new enemy, or a third new enemies to the player, and so we were thinking like how is that like, can implement the like difficulty system? Like, is it possible, like for example, the player don't have the first upgrades yet, and we just don't spawn the second enemy.
Yeah, that's definitely doable. What you could do, a few different ways to track where and how you want to do it, but I would probably have basically like a global variable that's just like the player, let's call it difficulty. And when you get an upgrade, you can just increase it by some value. So maybe you're gonna say you have 2 upgrades, and each upgrade is gonna give you like 0.5 difficulty. So you pick up the first upgrade and you change that global variable from 0 to 0.5. When you pick up the second one, it'll go from 0.5 to 1. And then your other systems, like your enemy spawners, can read that variable and go, okay, if it's 0, I'm going to spawn this many enemies, or this type of enemy. If it's 0.5, I'll spawn this group. And if it's 1, I'll spawn like the toughest group. So that's definitely doable.
Yeah, also another question about the camera, because it's asymmetric. What happens like if there's a wall and the player moves here, the camera will block the character?
So that's an interesting topic that a lot of students have struggled with. There's a few different ways of doing that. You can do it with shader. You can basically detect if a wall's in front of the player, and you can kind of carve a hole in it. My best recommendation there, though, instead of doing that, you could actually talk to sneaking around.
I'm part of this class. I just bitch a lot.
You can talk to Pradeep. His final project had a lot of this problem. They kept reworking their wall system. The best thing to do, honestly, is just don't put something in the way of the player. Even if it means it's kind of unrealistic. Like, I think you can see a good example of that kind of stuff is things like Diablo 4 gameplay. How they do their dungeons.
So just make it like the wall of transparency or something?
Just make it a low wall, and you could even sort of explain it with like, you know, in-world reasons. It could be a wall that's collapsed, so it's like a half-high wall. But you notice all the stuff in front of the player here. This is a wall.
So I kind of wonder like what happens if player moves here?
So that's the thing. They design your levels, or they design their levels so they don't.
Oh.
That's just sort of a level design issue. I would make that more of a level design problem than a code problem. You can see there might be a bit of it here. Let's see what they do when you go through this door. They might have an effect here where this stuff disappears. I'm not sure.
Right.
Yeah, so they did that.
Is it like
So for something like that, what they probably have, you can see how it kind of fades out, is they could have some sort of code running that's basically just doing like a raycast to the player, and to detect something in the way, it can modify its material to basically fade it out. And then, yeah. Well, it looks like that's interesting. Once you walk by, it doesn't turn back on. It's just gone. So it looks like it's permanent. That's interesting.
Thank you, Chris.
Yeah.
I didn't know that.
Because the glass is like,
Exactly. Set it for me.
Yeah.
I didn't know it was not true.
I knew it was. Like,
Yeah.
I've never been grown.
They don't grow very well, so it's
I know. That's what I mean. This is so loud. Accidental download not afraid to just turn it off. Yeah, I think everything I was gonna say about it. I should. Since then, I thought that she would.
Yeah.
No, I know. They're just really big. Aren't really.
Good.
Yep.
I wanted to ask you something.
Yeah.
Because I was trying to set up a vertex shape the other day for like a prototype for my team project.
Yep.
To do like displacement for the water.
Yeah.
And I put in a plane to do it, and it's just I can't figure out if there's a way to get more vertices on the plane.
Yeah. So what you want to do is tessellate it.
Yeah. Do you know how I would tessellate it?
Yes. So in the shader settings, let's go make a random shader here. Lit unlit doesn't really matter.
Yeah.
But in the settings,
Also, does it matter which render pipeline we're using? Because I was using the universal one.
you are using the support tessellation.
Okay, that makes sense then.
Yeah.
Perfect. So
Yeah.
I need to use the HDRP.
Yeah.
Okay.
Yeah.
Because I didn't use this project. I just made one from
Yeah, yeah,
scratch.
yeah.
So
That's one of the reasons we use HDRP. Is
Okay.
there's still missing support for some stuff like that.
cool. Okay.
Yeah.
I would love to hear those so that I
Yeah.
can.
So I always forget where it is, but it's in surface options. Let me see.
My hair's been
Where is it?
Get the 5% of your shares. Buy his team deck.
None of these categories make any sense. Oscillation, there we go, checkbox. Yeah. So turn that on.
And then
And
it'll
then
just.
when you want to do the offsets a little bit different, instead of affecting the vertex position,
Yeah.
you use tessellation factor increases the amount of tessellation, and you use this displacement that'll actually move vertices. So if I
Cool.
really quickly get in some noise, noise, and I think it's in world space.
It feels so bad. It's like I'm losing so much hair.
Dude, right? It feels
so much hair. It feels like I'll see my hairball.
Do like a plane.
Okay.
do that.
Perfect. Awesome. That's like exactly what I was.
Yeah. So the one thing with water, it works okay. Just keep in mind, one thing with tessellation is shadows start to get kind of wonky.
Yeah.
In Unreal 5, they actually just added this stuff back in, but they just ripped out tessellation when they added in nanite and lumen. Yeah, they just got rid of it for quite a while. 'Cause it is a little bit wonky.
Interesting. Okay.
Yeah.
Another thing I was wondering is I was trying to figure out how to actually like randomize the noise texture because the offset UV. I couldn't get any of like the time, like time, ghost time, any of those things to affect it in a way that actually made the noise still be noise.
Oh,
It was
okay.
just going to like black, white, and gray
Okay.
over all the whole thing.
So for something like that, what you want to do is typically with a water surface, rather than worrying about the UVs, is you would use the position, and we probably want to use the absolute world position.
Okay.
And I can split this and make a, UVs are vector 2. We don't care about Y. Since it's water, it's probably going to be flat. We'll use the X and Z.
Okay.
And use this, and then we can go and do a parallel offset.
I didn't even buy it.
Okay.
I just made it to
And then you can add, yeah, it's the preview gets kind of messed up.
Okay, that's what.
Yeah, you can add time to it. There's that.
Nice.
And this will all be done in
Very
a
quickly.
little fast.
Very fast, but
You just multiply that quickly.
What was it? Christmas Eve? No. I'm going to be DC.
Like that.
okay, perfect.
Yeah.
Yeah.
And the cool thing about this is it's done in world space position. So if I make like a duplicate of this,
It's not gonna be.
it all lines up because it's set up
Oh,
in
that's
position.
when I.
Yeah.
Okay, perfect. Thank you. Appreciate it.
Yeah.
Because yeah, like there's like one part of our level is gonna have water, and I'm
Yeah.
like, you know what? I want to try and figure that out now, so that later on I can just like get into the proper
There is also like the water system, but it's like super photorealistic, so it doesn't fit with a lot of student work.
No, definitely not. It wouldn't fit with our game whatsoever. We're doing a 2.5D kind of cartoon noir fantasy
Yeah.
thing, and it's
You
like
can you can modify that shader to do more toon-like effects, but I found it's more work than just creating a new one.
I'd say for me, honestly, our game, I feel like just literally having it be like a slightly reflective surface and having them all be flat planes is exactly all we need.
Yeah.
So like it is like technically 2.5D using 3D assets, but it's like an isometric kind of orthographic thing.
Yeah.
It'll kind of look 2D anyways, and so having the water look kind of 2D as well would fit best.
Yeah.
Thank you. I appreciate
Yeah,
it.
I'll just a sec. I'll send a snip of this to you.
Oh,
as
awesome.
well.
Thank you.
Highlight the important installation checkbox.
Yes, perfect. Thank you so much.
Yeah.
I appreciate it.
No problem.
Need to put some dessert for later.
Which
That's me. Awesome. Thank you.
yeah.
I would hate to look at how do I feel? How do I feel? Yeah. But you feel like that, Rich. Go after the leader street before you but I immediately, my eyes were like, yeah, I think that's just like private. Like that's just how I naturally think, like seeing the private after private. I'm just saying, I don't think that's all.
Wonderful artists.
You're on your way. I don't know where you're going. You're on your way.
All right.
20 hours.
That's what these are for.
Body's like, hey, yo, what the fuck?
All right, we're going to continue. So, as requested, we're going to look at a sort of top-down isometric camera next. I know a few teams are doing similar things to that. And I'll talk a little bit about why, for 3D stuff, I'm not a big fan of a straight isometric camera. I kind of like to do the trick we did here, flattening it out, but we'll discuss that more later. Okay, so for this one, let's go into, there's actually a scene set up for this already. Let's go into the 3D isometric one, which is a little bit of a lie. This camera is actually not isometric. Yeah.
What?
Yeah.
Subscribe.
But you can see the general behavior here. If you hit play, we can run around. And this is the same, if you actually go into this scene or the 3D platformer or the first person one, it's the same geometry, the same character movement, all that stuff, just different camera angles.
It's a 3D.
Yes, so this one is 3D. So sorry, when you're saying 2.5D.
I always think 2.5D is 3D assets, but 2D movements. So
Yes, yeah.
But this has depth and height. So this is like
Yeah, so this is fully 3D. It's just a sort of isometric camera. The whole isometric camera is thrown around a lot. Some games are actually isometric. Some just have a top-down view. I kind of like to say top-down camera more because it's more specific about what's going on. Because you can also have like an angled isometric camera that isn't necessarily top-down.
Hades is like isometric because isometric is like kind of from an angle, right?
Hades is nonsense.
Great game.
So they actually have a really good talk on it. But let's go to some gameplay here.
You've uncovered a trigger for play.
Yeah. No, it's just their art pipeline is wild. So everything in this scene right here is 2D, including their real-time shadows.
What?
Yeah. It's all 2D.
Isn't it 3D like there's a documentary where the artist talks about it?
Yeah. So I know. Do you remember what that's called?
No clip.
Hades, no clip.
They do like yeah, it's not just the artist, it's actually like the entire process. But
Yeah. So let's see if we can find their. Here we go. Yeah, this one from Supergiant. Yes, they are at that point, but not in the game. So I'll link this in your GD72 chat because it's really worth watching. But the way they do things is they actually follow pretty much the same pipeline we do. They ZBrush their sculpt. They take it into Maya to do their low poly. Still more modeling, modeling, modeling. Then they go into Substance Painter and they paint their character. Then they go rig and animate it. And from there, I think they actually don't show it. Or maybe that was their tool there. Maybe it's built into Maya. But they basically go through and they export all the 3D frames from their characters into 2D sprites. And they play those in engine. So they've been doing this since like Bastion, Pyre, which I did not like. What's their second game? Transistor? Yeah, all their games use this pipeline. Yes.
that looks cool.
It does look cool. The other thing is trying to mix and match 3D and 2D stuff in your world can get really messy. Figuring out what things are going to be in front of what other objects in 2D space can be really challenging. To get proper depth, like if you were doing it like an old school, let's see. Look at like Final Fantasy VII. No Rebirth. So old school games, this is fully 3D. Let's see if we can find their world map. Here we go. So a lot of the environments in this, these are just 2D images that they're moving their characters around on top of. Now, for the most part, you can't really get occluded by things. They have collision that stops you going like behind here and stuff like that. In order to get that correct depth, they actually have cutout sprites from the environment that they kind of line up so it looks like you're going behind them. But that can get really, really messy. Then you figure the other way of doing it is kind of placing all that 2D stuff in 3D space with colliders to make your character walk around the objects. And at that point, you're like, why am I making a 2D game? So converting everything into 2D, you don't need to worry as much about like all the collision and sorting issues because the engine can kind of sort that stuff out for you since it's all sprites, which is why they do all that. Plus, when it comes to actually playing the game, their requirements are a lot lower, so they can port to like Switch or whatever with really no performance problems. Since there isn't really any 3D
So
stuff.
Collision, so when it's 2D collision, it's easier and it's less intensive.
Yeah, and also just 2D rendering is a lot cheaper because it's all sprites. It's actually two very different looking games, but I think we talked about this one before, but Dead Cells.
Does Ori do this too?
Also really, yes. So the first Ori did this. I believe the second one is actually 3D.
Huh.
When is it coming out?
What? Ori 2?
Ori 2 is awesome.
It's been out for years. Okay, so good example here. Dead Cells, very, very similar. They have a tool. They do it in pixel art, but they rig and animate their characters in Maya. Now, the difference here with Dead Cells is they don't paint everything before they export. They export it all with basically color IDs, and then their tool allows them to go in and change all the different color pieces to recolor characters. And then they play it all back. Now, Hades is entirely 2D. They still have some sort of 3D looking lights that they kind of mimic in 2D. Dead Cells has an extra effect where you can see the lighting actually changing on the character during his animations. So in theirs, they actually also, since they start with a 3D asset, they bake out normal maps for their sprites. So they apply those normal maps onto the 2D characters. So the lighting actually affects the surfaces and the lighting changes as you move like past characters.
Why did Ori stick to 3D in the second one? Because he just said like it saves on performance for the Switch.
It just skips that whole step. When you go and update a character, it's updated immediately. You don't have to go through that whole pipeline. Yeah, I think this stuff, I could be wrong on this, but I think this is more, yeah, I think this stuff is actually 3D. But I could be wrong. I know in the first one, they did show their tool. They had a similar thing where Ori was done in 3D and then exported out as sprites. But yeah, I'm 95% sure this stuff is all 3D. Some of the stuff they're running on, since it is sort of a 2.5D-ish game, I think there are probably a lot of 2D assets in the level anyway. Yeah, like a lot of this background stuff, there's no need for any of this stuff to be 3D. Same thing with these. Another interesting game that does something similar. There's actually a really cool GIF of it. Is Hollow Knight.
Yeah. Wow, I never heard of it. It's the called.
What's Hollow?
Why is it Hollow?
It's all 2D sprites.
Yeah, why is it full?
Yeah. So here's a good example. This is them in Unity. So theirs is sprites, but they use a parallax effect. So they're 2D sprites in a camera setup that kind of parallaxes them across each other to create that illusion of depth, even though everything is entirely 2D.
That's not layering, right?
Yeah. So some games do this manually, where they will actually through script move stuff in the background as the player and camera moves. Other games, I'm not sure exactly what Hollow Knight's doing. There is actually distance there, so Hollow Knight, like some games, might actually just be placing things and leaving them there, and their camera's actually not 2D, it's slightly 3D to get the effect.
That is how Hollow Knight does it.
Is it? Oh, okay. Yeah.
Because I use the same technique that they use, because what that means that they don't have to, for their sprite work, because it's all vector,
Yeah.
they don't have to worry about scaling it in engine, so they can use all the same props just scaled up in their backgrounds. And
Oh, okay.
To keep that 3D space while also
Cool.
utilizing the same sprites. Because it was built in 2 years. So
Yeah.
they needed to reuse as much as they could.
Yeah.
Must have been like 40 people on it, right?
It was actually pretty fun.
That's pretty impressive. Yeah, so there's a lot of cool tricks you can do to kind of simulate and fake depth in a lot of games. Again, this is obviously a lot cheaper to render and easier to port to different systems than having like a fully 3D world. And then you've got kind of the flip side, a lot of these optimizations, you've got stuff like Cuphead, which took them how long to make this game?
Long
Forever, because they just hand drew absolutely everything. Yeah. Yeah, this is like painstaking.
Very small team.
I think so, yeah.
Yeah, I think so.
If you want to check it out, I'll link this article about Dead Cells as well. Dead Cells actually has a lot of good content online if you look it up about their development. It was originally like I think it was like originally a multiplayer mobile tower defense game. Like it was completely different, yeah. Okay, so setting up our own kind of top-down isometric-ish camera. We'll go through that next. So we're in the 3D isometric scene here. In our scene, I'm going to right-click and go down to Cinemachine, and we'll make a virtual camera again. Just like before, I want to make sure that this camera is the one that's kicking in. So I'm going to set its priority to 20, so it's taking control away from the camera that's already in this scene. For our setup, we're going to do our same thing. We're going to follow and look at our player. We're going to change quite a bit about where the camera's positioned and how it's following. So I'm going to go into our little character section, and we'll drag our player into the follow and look at here. So we're going to follow our player and look at our player. And our default settings, if we hit play after plugging the player in, are going to be real wild. Perfect. Camera is done. So we're going to make a bunch of changes like we did before. Again, one of my favorite things in Cinemachine is that framing transposer, so we're going to use the same thing here. For our body, I'm going to change it from transposer over to framing transposer. And I think what we'll do, rather than have the camera look at actually functioning, I think we're going to end up doing this similarly to what we did before. I want the camera to basically look down at a fixed angle and just follow the player around. So what I'm going to do for the aim is change the aim system here. So right now the body is a framing transposer. I'm going to change the aim to do nothing again. I guess possibly we could do a hard look at, but we want to manually control the camera anyway. From there, we can start to adjust the angle of the camera. Remember, just like our previous scene, if I start to adjust the X angle in our rotation here, we're going to start to move the camera up. And if we want to get that kind of isometric look you see in a lot of games, we probably want to rotate it on both the X-axis, so we're kind of looking from on top, and then also adjust the Y-axis a bit, so we're also looking at kind of an angle. And again, totally up to you. A lot of isometric games kind of snap the camera on 45-degree angles. So here I've got 65 degrees for my X and minus 45 degrees for my Y. Now the problem here we see is similar to what we had before. When I hit play, we get that very weird perspective look to our game. The wall closer to my camera is very obviously bigger. We're getting some weird kind of warping. We want to kind of get closer at least to that isometric view. So we have kind of two different options here. We can either change the camera entirely. Where do we want to do that? So we've got two options here. We can switch the camera over to purely orthographic mode to get like the traditional true isometric view. If we want to do that, we're actually going to go up and do this on the camera itself. So inside the camera section, we have our main camera. In rendering, wait, no, that's wrong. Sorry, not in rendering, just up here in projection. We can change it from perspective to orthographic. So that flattens it out, and we can see the difference there. We can switch it to orthographic and try running around. And we have an orthographic view. But switching from one to the other can be kind of weird feeling. I will recommend, we had one team that had in their game, they had an isometric top-down camera, but then they had cutscenes where the camera would come down and switch to perspective. And it was the weirdest, most jarring thing. It was kind of like we saw previously, where you have the camera do that like creepy Stanley Kubrick, like zoom in while the camera angle changes things. It was like super unsettling. Yeah, exactly. It's the trolley shot. So they left that in, but it felt very weird. So I would recommend, if you're going orthographic, stick to orthographic, rather than like swapping back and forth between orthographic and perspective. So with it set to orthographic, we can now start to tune it kind of like we did before. Now remember, our camera distance, we'll zoom our camera in and out, but doesn't actually make anything look different because we don't have any depth. We need to change here the lens ortho size to zoom in and out. then we've got a lot of the same settings we used before. Now, one of the problems with orthographic stuff is actually when it comes to rendering. So the pipeline is actually handled a little bit differently when you're working with an orthographic camera, and certain VFX and shader tricks don't actually work when you're purely orthographic. So just be aware of that. A lot of shader effects that rely on depth aren't going to function correctly because they're kind of skipping that part since everything's orthographic. So if you're ever doing, I was actually just talking to Connor about a Unity water shader. Something like this that's using like a depth effect. To get these kind of effects, you have to jump through a bunch more hoops to get it working in orthographic, so just be aware of that. If you end up going fully orthographic and you're following a tutorial for water or something like that and it doesn't work, that is the issue. So that's just one thing to be aware of. Basically with orthographic, since we're not rendering in perspective, it skips some steps when it's rendering, so that information is not available to us when we get to the shader stage. Yeah. We can still sort of reconstruct it from other data, but it's a little bit wonky. So again, one thing we kind of recommend for that isometric look without going fully orthographic, we can do it similarly here on our camera. Instead of being an orthographic, we can reset it to perspective mode. And we can do the same trick before we lower our field of view, something like 20, and then zoom our camera out. This is kind of how I like to do it. So the effect here, we're not purely orthographic. We still are perspective. So you can see how we can see the sides of objects as we kind of move around more. We still have that top-down look, and things are still kind of flattened, which makes visibility a bit easier with this camera angle. But we're not truly orthographic, which I kind of prefer. Now, one thing I want to show you while we're here, since this is a camera angle that a lot of like local co-op type games use, we can set up a special type of Cinemachine camera that can track multiple characters or multiple objects, kind of however we want to do it. So we'll leave our virtual camera here, but let's go and create another type of virtual camera to track our player. So I'm going to right click and go down to Cinemachine, and we're going to create this thing called a target group camera. When we do that, it actually creates two different objects here. We have this virtual camera, which is called Virtual Camera 1. And we have another object created called a target group. So this Cinemachine target group component, we plug everything we want to track into this component. And then the camera points at it and goes, oh, okay, this is a target group rather than a single target, and it automatically adjusts to keep all the things in our target group in frame at all times. So what we'll do is, might be a little bit goofy, but we'll go to our target group, and I'm going to add 4 entries. And I'll throw some random stuff into it. So I'm going to put the player in our first slot, and if we open up world and go into dynamic, I'm going to plug the cubes and the moving platform into it. I'll come back to the scene really quick, but just to see it in action, we can actually watch the target group here. And as things move around, we can see our moving platforms moving. The center of our target group is moving to always be in the center of these two boxes, the player and this moving platform. So it handles moving around for us. It's really useful for kind of targeting multiple things simultaneously. So you got the target group camera created? Yeah. So on the target group itself, click this little plus button 4 times. You see a bunch of like empty fields. Then I plugged in the player into the first one. And then in this world section under dynamic, you'll find the cubes and the moving platform. Plug those in as well. Now, I just did this for this example since they're moving around, or at least in the cube's case, we can push them around. But these could be other players. This could be an enemy. You could even do some cool stuff where this could be like an objective on the map. You want to show the player for a second, so you can turn it on and the camera will kind of highlight both, and then you can switch back to your normal gameplay camera again. Oh, so right now it's not going to be working, so remember that priority system is in place. So on our virtual camera 1 that's pointing at the target group, we had set up our standard camera has a priority of 10. Our new camera we created had 20. Let's change this new one, the virtual camera 1. I'm going to change the priority to 30. And I think it's going to be very wrong. Yes, it is, pointing it through the wall again. So we can change it to work kind of like our other camera again. You can see how it's set up a little bit differently, where the body is set to a transposer and the aim is set to a group composer. We can use these to kind of change how this camera looks at our objects and then kind of tracks them. So right now, the binding mode, it's set to lock to target with a world up. Right now, the position here, its Z is -10, which moves us behind the targets, but we're not above them. So if we start to increase the Y value, see our camera goes up. So set the follow offset here. I've got it at 0, 15, and -10. As I run around, it's going to keep all those objects in frame. Now, one thing I don't like about the default settings with the with this target group camera is it's using an aim system and it's zooming in and out. It's also rotating the camera slightly, which is kind of creating sort of a cool organic, like there's someone with a camera watching these objects. But for gameplay purposes, it's also very weird having your camera tilt slightly, especially if there's a bunch of different people running around and they're all kind of influencing it differently. So there's a few different ways to tune this camera. What I'm going to do to set it up to feel more like the previous camera, but still try and keep all these objects on screen, is I'm going to go and do some of the same settings. So for the aim, I'm going to change this again to do nothing. So my aim on this new camera, I'm going to set to do nothing again. I'm also going to change my lens vertical FOV, again to 20 to flatten everything out. And we're again going to use my favorite little body option there, which is the framing transposer. So the framing transposer hooked up to the body will move our camera around and try and keep everything within frame without doing any weird tilting or aiming of our camera. So I'm going to change the body to be a framing transposer. Now if we hit play, it's going to keep everything on screen. You'll notice there's no weird tilting going on. It's still zooming in, probably way too much. But it's properly keeping everything on screen. So there's a couple different options, I guess 3 different options for how you want it. Basically, it's strategy for keeping stuff on screen. It can go and zoom, which is changing our field of view. It can dolly, which means it can basically move in and out to get closer and further from our targets. Or finally, it can do both to try and keep everything on screen. What I like to do most of the time is change the adjustment mode to dolly only. So what it's going to do is it's going to just move the camera in and out to keep everything on screen without changing our field of view. I find changing the field of view of a gameplay camera while the game's running feels very strange. The one issue with this method is that if things end up very far apart, you can see I'm basically moving the camera off screen. So you kind of have to plan around that. We can set a min and max dolly in and out to keep it on screen, but be aware if you clamp it too small, so our characters are running very far apart from each other and we can't zoom out enough, it means they're going to go off screen. Some games have some strategies around that. You could add like an inverted collider to your camera so characters literally can't run out of the screen. They bump into stuff. But it kind of depends how you want your game to work.
You said put a collider around the camera's view.
Yeah, so you could literally just put a collider that's turned inside out, stuck to the camera, so you have sort of like an empty space the character's can run around in, but they'll bump up against. Yeah. And so we can make some changes here. My minimum distance right now is set to 1. I'm going to turn that up a little bit and say my minimum distance is going to be 20, and then it's up to 5,000, which is like 5 kilometers. A little bit far, so I'll say maybe like 50. Yeah, this will keep everything on screen for us. Kind of like the other stuff, we can mess with the camera settings. If you're finding characters are getting to the very, very edges of the screen and they're kind of too far off, I might not notice my player in the top right here. You can adjust the safe zone and these framing size settings to keep everything more in screen. So if I drop the group framing size down to like 0.5, it'll zoom out more to keep stuff on screen. So there's less chance of a character getting too far outside of the viewable space. This target group camera is very handy. Now, it's not just for like player characters. We've had some games making either 2D or 2.5D games that have had systems in place where they walk up to like nice set pieces of art. There might be something quite big, or a good example would be, let's see, a game like something like Blasphemous, where you might have a really big character you want to zoom the camera out to see. You can adjust those and actually play around on the target group. There's this weight and radius, which controls basically how much it's going to follow that one thing. And then the radius is how big that thing is on the screen. So if you crank the radius up, it'll try and zoom out more to capture that object. So you can kind of create cool moments where you like walk into a room in your 2D game and the camera like zooms out to show a bunch of it. And as you walk out, sort of transitions back into your normal camera.
Is it like a cinematic that's happening, or like real time? So you're walking.
Could be either.
Wouldn't it be janky if it's real time because the player can break it sound like coming out, like leaving around?
Yeah, normally you have some sort of threshold there, so it kind of slowly comes in rather than like flipping from one camera back and forth, which can be very weird. My favorite example of that isn't so much a camera thing, but I love this video. Just a sec. I think this is the one. I don't even know this guy. I've only seen this clip of him. But he's playing a horror game, and he does exactly what you're mentioning. He finds the trigger that has this little, like, ghost kid run, except the kid, for some reason, smacks its head in front of you. So it does that. And he realizes the trigger is right here. So he spends 5 minutes just, like, in hysterical laughter, stepping in and out, like shotgunning, like, 10 of these kids at once into the wall. The goofy thing is they kind of set themselves up for this too. Just because this area of the game loops you around through the same places over and over again, so you're bound to run into the same trigger more than once. They should have done something like that, or have a cooldown on it, or make you walk out of the area before it happens. But yeah, he figures out the exact spot where he can do it. And he's just doing it over and over again. Yeah. I've got the audio turned off, but you can hear this like cartoon thunk sound every time it hits its head too. But yeah, stuff like that can break immersion very quickly, but done well, looks okay. Same thing with cameras. Okay, so we've done 2D camera, we've done a 2.5D camera, we've done like an isometric camera and a group camera. Still a couple more I want to do. I'm going to take a look at a third-person camera running around behind a character and a first-person camera as well. And I think we'll do the first-person camera first because that one's a little bit easier to set up. So we're going to go into the first-person scene next. Yeah. Oh, right. Sorry?
We're gonna do third person.
Yeah, we'll do third-person last. So we still got, you can leave them on if you want. It doesn't actually really matter. We do have our custom volumes in here right now. If we look at the existing character, we have, just like the rest of our setups, we have a player and we have a player Cinemachine virtual camera. Now the difference with this one is this Cinemachine virtual camera is actually taking input from the player because it's a first-person camera. So we're using a special component on the aim section called POV, which can take input from the user and actually rotate the camera around for us. Now, this is really handy because it takes care of all the rotation nonsense we normally deal with. It's got settings for things like clamping the angle so we can't look up behind ourselves or do anything weird. It's got all this stuff kind of built in, so it's really, really useful for kind of starting with a camera. Now, what we're going to do to hook things up is we'll create our own camera that's going to sit on top. So inside our scene here, I'm going to right click and go down to Cinemachine. And I don't think they have, they don't have any sort of default for this. So we're just going to start again with a basic virtual camera. Now, there's a couple different ways. Oh, yeah.
For like horizontal, I think the clamping for the vertical. Wouldn't you just make the camera like a child of the like player character? So like.
You don't really want to do that because it means if you slow down your character's turn speed for animation's sake, it means you're slowing down your character's rotation. It can feel very weird. Yeah. There could also be weird sync issues where if you have like physics affecting your character where it's like moving the camera when you don't want it to.
Oh yeah.
Yeah.
Okay,
yeah. So what we're going to do here to start with is we need to figure out how our camera is going to follow our character around. Now, there's two different options. We can either have it follow the character and just sit at head height, or I do a little bit of a cheat to get some natural head movement, and I actually have the camera follow around the head bone. So I've done a trick here where the character actually has full geometry. I just have it hidden. So the character is still playing its normal running animation as it runs around. So if we have the camera follow that bone, we get the head kind of bouncing up and down. It also means we automatically get a crouch system. If we add a crouch animation in, our camera will go down and we can move around. So sort of a cheap shortcut to getting those effects in. So what we're going to do is grab our virtual camera, and I'm going to take a look at my player and open it up. Inside the player, there are 5 objects. We have 2 objects that are very weirdly named. One is alpha joints and one is alpha surface. Those are just 2 different meshes that make up the character. And then we have bones for the head and the left hand and the right hand. So I'm going to drag the Mixamo rig head into the follow section. Let me just double check. Yeah. For the look at, we're going to go none because we're controlling what the camera's looking at. For the body, what we're going to do is we're going to have it follow that bone directly. So instead of a transposer, I'm going to change this over to hard lock the target. That literally just matches our camera exactly where that other object is.
Drag the head object into?
The follow field on our Cinemachine virtual camera. Yeah. I just realized while we're here as well, we can adjust the field of view. Let's go, turn our priority up. So our field of view right now is set to 60, which is kind of low for first-person gameplay. kind of depends the kind of first-person game you're playing. If it's like a walking sim, it might be on the lower end. If you're playing like a competitive shooter, it might be quite high. But normally you're going to see between like probably 75 and like 110 there. 110 just for like very, very competitive shooters. Most of the time it's going to be between like 75 and 90. So I'm going to set my FOV right now to like 80, which will be more realistic. Okay, for the aim, we're going to change this. Instead of composer, we're going to set it to be POV. So that's point of view. And that POV component automatically comes with inputs. If I hit play, I can actually go look around, and it's working. Now, the one problem I have with this, if you play a lot of shooters, you'll find this is very floaty. I go and move the mouse really fast and then stop. There's a lot of easing, which again, if you're making a walking sim or just some sort of interactive game that isn't like super fast paced or relying on aiming, probably feels okay. Yeah, exactly. But if we're making sort of a, very accurate, fast-paced game where we need to quickly snap our camera around and look around, we're going to want to tune some values here. So inside this POV component, we have two sections here, two main sections we're going to deal with, the vertical axis and the horizontal axis. So the vertical axis is how we can look up and down. The horizontal axis is how we can look left and right and spin all the way around in circles. I want to make a few adjustments here. So the value range on our vertical axis, minus 70 to 70 is kind of restrictive. If we're trying to shoot down or up really high, actually it's not terrible, but I want to give a little bit more leeway there. I'm going to set it from minus 85 up to 85. There's an option beside that for wrap. The horizontal rotation we want to wrap. If you turn on wrapping for vertical, I think that's going to get real weird. Yeah. Yeah, that's not great. So we'll leave wrap turned off. The next thing we're going to adjust is the speed. So there's a couple different ways of doing input speed here. Right now it's set to max speed, which feels pretty good on like a controller. It basically scales your input against some sort of maximum speed value and moves the camera accordingly. And then there's a bit of acceleration and deceleration added in. What I'm going to do is change the mode. So for the speed, instead of max speed, I'm going to change this to input value gain. We play again, I think our camera is going to be completely uncontrollable. Yeah. So when you convert from one to the other, the speed for the input value gain is going to be a lot smaller. I'm going to try changing it to, like, I'm not even kidding, like 2 and see how that feels. So from 300 down to 2. That's a lot better. Now you can feel the difference. Going up and down is quite snappy. Turning left and right still has that easing effect in. So we can set that one up to behave similarly. Yes. Yes. There we go. Better?
I don't feel
Okay.
that one, right?
Yeah, that's what we made in class.
Yes.
So the next part, actually, I'm sort of skipping a part and ignoring it. They have vertical and horizontal recentering. We're not making a shooter for my grandparents, so we don't need to turn this on. If you are making a game and you are assuming your players are going to like take their hands off the aiming stick a lot and you want the camera to recenter itself automatically, you can turn that on. That's something I normally turn off immediately when I feel it in games, but certain games have that stuff enabled. It's more useful in like third person or like in driving games. Okay, so lastly, we have the horizontal axis, which we're going to make similar changes. So right now it's set to max speed. I'm going to change this also to input value gain. And the speed, I'm going to change this. Now, it's going to be interesting. Again, if we hit play, it's going to be way too fast. Yep, I can't really control that. What we're going to do is we're going to lower the speed quite a lot. I'll try 2 again, but I think that might even be too fast. So what's kind of weird is that the values here are slightly different. You'll notice that the value range, like minus 85 to 85 here, but for the horizontal axis is minus 180 to 180. It's a full 360. So you can imagine if you're kind of equating them and saying, okay, looking up from all the way down to all the way up is going to take me this much time or this much movement of my mouse versus horizontal, it's going to take a lot more movement to go kind of horizontal. So it kind of speeds things up. So if it feels okay for you, you can leave it, but I think I actually don't mind my horizontal speed, but my vertical speed seems a little low. So I'm going to change my vertical speed to 3. That feels a bit better. It's actually sort of an aside, but it's going to come up both for your team project and your final project. When you're demoing your game, pick someone on your team who demos the game well. We've had some students that play like an E3 presenter. They're just run around like super smooth and like look at like props and stuff as they go through the environment, do a great job showing off their game. I myself, when I play shooters, am like doing this the whole time, which does not present well. So I'm not normally the person you'd pick for that kind of stuff. So keep that in mind when you're demoing your game. Okay, so the last thing we're going to adjust here is it has this accel and decel time. This has less of an effect when you're on the input value gain setting, but if you want, again, like fully snappy kind of movement, we can set all these down to 0. So that's the accel time and the decel time. That feels pretty good. Go. So the last type of camera we're going to look at for gameplay purposes is going to be like a third-person follow cam. You can see in a lot of like third-person games. They could be a third-person like melee combat game, or there could be shooting. You can kind of tune it for both. We'll take a look at that, and we'll also look at some other kind of systems that Cinemachine has with things like screen shake and noise and all those kind of settings we can play around with. We'll also look, Cinemachine has a built-in system that will have a collider set up so your camera doesn't clip through walls. It's got that ready to go. And then we'll take a look at how we can blend some cinematic stuff in with those cameras as well. But we'll take a break first. Let's start again at 3:05. We'll go and hop into our third-person follow cam.
When I have a question.
Yeah.
For Unity packages.
Yeah.
Say we install a plugin to make our Flash Droids game.
Yeah.
Would that transfer over once we make the Unity package or
No.
no?
Yeah. Yeah, that's actually a good question. I've been meaning to talk to the Unity instructor about that. I'm not a big fan of handing in Unity packages for projects because it loses all of that stuff. Your best bet would probably just add a note to your instructor saying, hey, you have to install this package as well, because it won't even compile or play if you don't have that. Yeah. Yeah.
Is there a reason why you prefer Fork over what's it called?
GitHub? I know Steven's been using GitHub Desktop with you for level design stuff, right?
He just started just
Yeah, yeah.
tried forking it.
Yeah, I know he does. Steven's very picky. The reason why, so GitHub Desktop, if you're working on a solo project or doing portfolio stuff, it's fantastic. Super slick, super smooth, great experience. The problem I have with it is that GitHub Desktop is missing, let me open Fork really quick, is missing a lot of the nice visual display of the history of your project with this kind of stuff. So it doesn't show all your branches. It's also missing a lot of features that handle things like merge conflicts and merging different branches together easily. So that's kind of why I don't use it. If they added that stuff to it, I'd probably stick to it exclusively. But it's really still missing those important features. It's really good solo. Working in a team, it kind of falls short. Okay, so we're on break. We'll start again at 3:05.
Yeah, I still think you should keep it right before you still need to. You didn't need to, man. You have gone for presentation. Actually,
Do you have a Steam Deck?
I don't.
Derek is selling his used
Oh,
300
yeah?
bucks
$300 for a Steam Deck?
because the OLED just came out, and then
Oh.
they
Buying
basically
the new one?
they made the newest OLED one the same
Yeah.
price as the previous iPad, so it's cheap.
Wow, it's way cheaper. I know Pradeep just sold his Switch to get a new Steam Deck too.
The new OLED is really nice.
Mm.
You're not going to think about getting it.
It seems like a cool gadget that I'd play with a lot for like a week, and then it's because one of the problems is there isn't like compared to like the Switch that has a lot of exclusive games. There's no killer app for the Steam Deck.
You know, you can install the Switch emulator
Does
on
it
the
run
Steam
on
Deck,
it?
and it runs
Okay.
better than the Switch itself.
That's funny. I did emulate Breath of the Wild on my PC for a little while.
I emulated all my Switch games onto my Steam Deck, and it's better.
Yeah, that's
Bigger
funny.
screen, better.
So that sounds like a cool thing, but there's nothing exclusive to the Steam Deck that would get me to play it. Like it's just I'm gonna play my existing
I
Steam
think it's
games.
just it feels so much nicer on the Switch too. You know, I did a really neat thing for the case. You can take out so you can have a smaller one. If I don't like updo it, I have full like this one is the same thing. 1,000 for the 1 TB, but then there's the 700 for the and there's like so this the 1 TB has a glass, which actually makes it less so people would probably go for 5
Ryan.
and then the colors are
No, what I'm saying is like use the same paper.
it's bigger than the Switch.
I was just looking at the
Everything is changed from the old one. Like everything is refined to the so trackpads
Not a field, but
joysticks are
I'm not saying
yeah, everything changed. Literally like this could be Gen 2 and they just upgrade the processors and stuff.
So,
But the battery life is 1.5 times.
like, say if you have it to the
So it's actually worth getting the micro version.
Yeah.
sphere
Or,
collider,
yeah,
I might get one at some point. I just bought a new VR headset, so that's my
Which
new
one?
toy. I just got a Quest 3.
you could have went for the big screen
I feel like, yeah,
VR.
I don't know, I'm not too sure what I want to do.
Which
You
is
don't have that one, right?
Give me
No.
Google it. It's so cool. I'm waiting for mine. It's coming December. It's called Big Screen.
Oh, I did hear that name, but I don't know what it is.
It's basically the next gen VR. Like anything you buy right now, other than big screen, is basically still last gen. Because of how small it is.
Okay. Oh, damn.
It's that small. It's lighter than your phone. And then sure the FOV isn't like that great.
Yeah.
But then it's OLED. It's like super comfortable because they 3D scan your face and then print out a mask just for you. So you can't share this with anyone.
That's wild.
They basically built in the FOV for you.
Yeah.
So it's basically
Okay, the other controllers.
Personal.
Oh, is he just using index
yeah.
controllers?
Everything else is your own stuff. Just the headset.
I like the. So the Quest was a Christmas present for my girlfriend, but the reason I like that is that everything's self-contained. So
Yes.
it's just another plan. It looked like they were wired in there. Right?
Yes, it is. Yeah. But then there's a company called I think it's No Field, they make wireless for the index and also HTC so far. They're gonna make one for this. So it's basically this little thing you put in your head and then you plug in like a Wi-Fi device into your desktop. It streams directly.
Okay, so
So it could be wireless.
I was looking at that for the Quest. I'm kind of skeptical about that stuff.
It's already proven technology.
So I'm not saying it doesn't work. I just saw a lot of reviews of that text, and you can feel the latency. It has a significant amount of lag over the cable.
I did not hear that.
Yeah, I've heard it's better than like I think the Quest can do
It's like
just
some
over Wi-Fi without an extra device.
Yeah.
There's a device you can buy that they don't fix it that can help, but apparently you can still feel the latency.
I thought Quest 2 you just I think I know what you're talking about, but there's also like a virtual desktop with streaming.
Yeah, it's just there's like
You're not gonna get rid of that now like Wi-Fi stuff.
so I got like a cheapo link as well.
But I think just everyone that used that, the review is feels like a completely new like, next gen thing because if you went from like 5 hours of VR in the past, like you 5 hours a day, you would use like 20 hours. I don't know, 10 hours. Because it's just that comfortable. You just don't feel it like because right now it's still full front heavy. Like the Quest is not that comfortable.
Yeah.
You need a better strap.
Yeah. Well, it's weird. I haven't picked up the other strap yet because I've read it's very dependent on your head shape.
Yeah.
So some people are like, you have to buy the strap. It's the only way to use it. Other people have tried the expensive strap.
Yeah. But having the back strap is a little bang, and also the weight counterbalance.
Yeah.
So
Well, it depends. Some of the straps they sell don't have a battery. It's literally just.
yeah, don't buy that one. The Quest 3 lasts like really short, and 2 also.
Yeah, that's why I got the cable. They can charge one.
So you don't like any cables? Because with that, like I just got like a ceiling thing that
That's fine.
and it feels really
Yeah.
good. I'm just waiting for that to come. Because I got the Varjo Arrow. It's like 4K, almost 4K, no, 2.5K grand. And then it's like super clear, it's eye tracking, so when you look at its works, like making it resolution better.
That's pretty cool.
But then like your computer really has to be PC.
Yeah.
So it's really nice graphics, but the colors are just darker instead of so it's not that expensive if you have them. If
You've already bought the expensive ass controllers, yeah.
Yeah, if you already have those, then you're fine. But if you don't, then
No, you are. Front based. Just to see the bug.
That's not what we're doing. Shut up. Oh, it's let's go. Yay, real. I disagree. A lot of people who are good at they're not putting I'll do it. And like I actually found Windows scripting easier. I started C# benching and now
It's easier to do easy things, harder to do hard things.
that is basically a good as long as you're doing what the you it's the best engine ever. The second you try to do something unique, everything goes on. Unless you make it. Sorry.
It's not bad.
So good. Gaming. It's so bad.
Pero bueno,
No wonder it just makes you put your scratch. You make scratch makes it muy bueno. Yeah.
yeah,
And it's
my dog, they like a
Starting helmet.
Well, you're almost there. So let's go. Well, we didn't do any.
I don't know, it's just the union.
Yeah.
If you're,
Well,
and
we're
after,
big.
well, everything's to next week, and there's no more arts.
Yeah. I mean, the Mega Man time.
Yeah, you said Wednesday.
No, it was this Wednesday next week, but he changed it to
Wow.
It's on Sunday.
He said next month. Beginning of last week. Yeah, he said yeah. You should have. Let's be honest, class is probably gonna be canceled anyway.
That's gonna be like, hey guys, you know what?
On Saturday, go past. Go past. I mean, I plan on doing like everything in UV by like Saturday.
So,
If you can come up, and then I can focus on doing the start, and then afterwards, only Unreal. What's the dog one? I forgot about it. There he said that's a later issue. What things to do? So that's next week.
I can't. I mean,
If you remake your game, yeah, or you pitch it.
I've used it.
I mean, everything's due next week.
Even though you
That's
pay
fine.
attention. I
But for me, if everything's next week, I'm like, next week is probably gonna so probably the weekend. I'm like, shit, I need to get everything. I need to get everything done this weekend. Yeah, otherwise I'm so screwed for the week.
Wait, tell me what's
Well,
the number.
it can be done.
Yeah.
I believe in you.
I mean,
You haven't done
That's why I wanted middle lab.
I gave up on it.
Yeah,
I just made the U shape. It's Kaiser shape. There's triangles. Whatever. that's my hands. I like shape it. It's a triangle. Nah. It's not my problem. Yeah, it's not like we're rigging it anyways. We don't even have to attach it to the body.
Actually, I was wondering if that's the moment that we are gonna use.
So Brian,
Yeah.
sorry,
Yeah.
Brian,
Yeah.
it appears that we do have to attach the hand. Yes. It appears that we do.
Ah, later.
This ain't no marble.
Later issue. Don't worry about it.
I worry about it all the time.
We'll take the hit.
Check this out. Check this out. You ready? This sword I made.
Okay.
Hey Jacob, come here. It's also relevant to you.
Wait, were you actually lucky? Oh, it's got lucky. Every time I get lucky. If you asked me one more time, I would have given up.
Está bien que cuando se enero ya me
Wrapping my
Unwrap God's gift. I don't know. Art autism.
So the UV is just literally like the model itself, but like put it to a 2D image so you can wash it.
Bota, güey, yo no quiero ver eso. No lo voy a ver.
You're in here to put the art.
What the fuck is
And it just wraps.
Cuando mi papá me pregunta en notificaciones, no voy a mandar.
You're the artist.
Oh, why does it do this?
Wait, Lucia, how?
O sea, en grupal.
No, so no, there are 3 comments that you well, there are not enough space.
not enough to avoid the fucking spaghetti.
It is what it is.
That's it.
Simplify it.
Bro.
He said he did.
It's fine. Just throw it on. Throw it on.
No, they're good. It's always just like getting all the meeting set up. We had one student last term. No, there's that. Another student got sick last minute. She was sick and couldn't connect. So she wasn't in like hot. And then it was the weirdest thing. Walking through going into her router settings. As soon as we walked in, we just walked in. But I had no idea. Literally just walked in. Didn't she think about herself? We're just in the settings working. So there's two portions. There's like an interview portion beforehand where you talk to students. And then there's like another portion where you're demoing the game. So combined it's 6 hours. It's 3 interviews where you're not talking all the time. It's sort of in and out of interviews.
Yeah.
And then the stream at the end is 3 hours.
Is it always different companies that come to see the baseball game?
Usually the same few, like
Double A, JD.
it's basically all local Vancouver stuff. Mostly kind of like AA plus United.
Welding companies much? Or
Yeah, I think mostly interview companies though, there might be some local, but I think they're mostly just sort of like local companies.
Blackboard Interactive, like
Yeah, although okay, we're gonna continue.
I can't. I gotta. You have seen how much sugar? Check this out. Check this out.
Okay, everyone back to your seats, please. We're gonna continue. Okay. All right, so we're gonna take a look at your like standard third-person action adventure camera now. So let's go into the 3D platformer scene. So this camera's a little bit different. It's more complex to set up, but allows us sort of the full freedom of motion to orbit around a character and also look up and down, and then we can add some more stuff to it. So to get started with this one, we're gonna right click and go to Cinemachine, and we're gonna create a free look camera, which I don't actually name the name of. It sounds like you're looking around. It's more like an orbit camera, but
It is what it is.
okay, so we're gonna right click, go Cinemachine, we're creating our free look camera. If you scroll down, you can see this one has quite a bit more going on, but the start of it is still similar to what we've set up before. We're gonna go and plug our player into both our follow and our look at fields here in our camera. So I'm gonna drag the player object right out of my hierarchy into the follow and the look at. Now it's going to require some tuning, but if we hit play, things will work. I forgot about that. The foot cam. We're going to have to fix that a little bit. It's also, oh yeah, I don't know what absolute psychopath wrote this, the default settings, but you'll notice, on top of the fact I'm zoomed in way too much, if I push my mouse up, I actually look down. If I turn my mouse, move my mouse right, I turn left. I have no idea who managed to get both of these backwards. Well, like with Flight Sim, you have like, it's kind of mimicking a stick, so you push forward and you like look down. I get that. But the whole move right and the camera goes left, I don't even know. Okay, so let's fix some of these default settings. So the first thing is the lens vertical FOV is at 40 by default, which is real low. For most games like this, I usually like the 60 to 70 range. So I'm going to go and change my lens vertical FOV here to like 70. Then we can go down and take a look at a few of the options here. So at 70 FOV, a little bit better, more zoomed out, but we still need to make some adjustments. First, let's make sure our inputs are actually going in the right direction. So you'll notice on our free look camera, we have similar to that POV camera, we've got a Y and X axis options. I'm going to go and just flip the invert option on both of these. So my Y-axis and my X-axis are both backwards from what I want right now. So I'm going to turn on the Y-axis invert. That's going to be enabled. And the X-axis invert is going to be disabled. That feels better. Yes.
Is there a way we can change the sensitivity?
Yes. So if you want to change the sensitivity around, you'll notice it's similar to the first person setup we did. It's using that same max speed setting, but you'll notice something a little bit different. So remember the previous one had the max speed and it was sort of in angles. So our up and down axis, looking up and down, went from minus 85 to 85. This system's a bit different. It's a little bit weird, but you'll see it has this value and it starts at 0.5. So what the system does is it actually creates, and they might be a little bit hard to see here. You can see there's 3 rings on my screen. One above the character's head, one kind of, I guess, both above his head, but one way above the head, one a little bit over the head, and then one around the feet. It has these 3 rings, and then there's a line, a curved line going through them. So this curved line dictates the path of the camera when you move it up and down, and then you rotate in a circle around the character. So rather than representing this position as an angle, it has a value between 0 and 1. We can actually move it here. Basically says where it is along that line. So rather than dealing with angles, we're just changing this y-axis value between 0 and 1. If you want to make things more snappy, we can change both of these again. Instead of max speed, we can switch them to input value gain. But you'll notice if we switch them to input value gain and hit play, it's kind of hard to move in a straight line. Oh, there we go. No, no. Oh, no. The sensitivity is way too high. So we have to drop both of these down a lot. Since we're dealing with this kind of normalized 0 to 1 value here on the y-axis, instead of thinking of these in angles, it's just sort of like a raw input scalar. So I'm going to lower this down by a lot. I'm going to say this is 0.02. And see how that feels. Okay, I can look it up and down all right, but horizontal rotation is still crazy. In fact, my up and down might be a little bit slow, but we can adjust it back up after. So one cool trick Unity does, and oh, thank you, Google Drive. Excellent, yeah. Perfect. You did that right now. All right. I lowered the vertical sensitivity down to 1% of what it was before. I divided it by 100. You can actually do math in the inspector. I'm not sure if we've done this yet, but if I go down to the x-axis and I'm like, okay, I dropped the y speed down by 100 in the speed here. Now, hopefully everyone can do this mental math themselves, but if I go speed divided by 100 and type it in like that and hit enter, it actually does that math for me. So it gives me 3. That actually feels a lot better. Now, comparing them, I'd say both feel a little slow, but my vertical is definitely slower. Now, what's interesting, in a lot of third-person games, whether they be like adventure games or shooters, a lot of the time the sensitivity vertically is actually a bit lower, since you typically don't need to look up and down as fast as you look around the character. But this is a little too drastic for me. Yes?
So when they go left and right, you don't actually turn or rotate?
Yes.
So to left and right, you have to do it.
Sorry.
Right now it's like rotating at the same time it's going
You mean the character?
It locks you almost on the path that you're liking.
Like when I'm doing this?
Yeah, like right in the cheap location.
Yeah, we'll fix that. So I'm going to change it to my vertical speed, maybe 0.05. Yeah, it feels a little bit better. So you can tune your settings to be whatever you want. But I think 0.05 and 5 is probably what I'm going to go with. And yes, there are some other issues. So once we have that sorted out, we can kind of look around okay. We're still looking at the character's feet, so we'll sort that out. But the other problem is you'll notice if we strafe, see how my camera kind of lags behind the player? And it makes me go around in a circle. When we strafe, we probably want to strafe just left and right without actually doing a circle. So we can correct that as well. First though, let's deal with the height issue. When I'm actually at the bottom, it's not terrible. Maybe I should actually look up a little bit more. But we can kind of adjust how this is offset from the player. So what I'm going to do is I'm going to go to this section down here at the bottom. Now, there's 3 tabs. You notice we have a top rig, a middle rig, and a bottom rig. Each of these activates as we kind of enter their area. So up here we have the top rig, then we have the middle rig, and then we have the bottom rig. So we're switching between these 3 different rig settings as we move our camera up and down. Starting with the top rig, we're going to change how this sits in relation to our player. We can fix kind of both of these problems at the same time. So you'll notice right now this binding mode up here says simple follow with world up. I don't want it to follow the character. That makes this effect. So if I actually start to turn the character, the camera kind of follows behind them. This is like a, I don't know, Spyro the Dragon style camera, very kind of old school. I'm not into it. I want full control of my camera. So what I'm going to do, instead of this simple follow with world up, I'm going to change this, click the drop down, and I'm going to change it to world space. So there's no following. We're just setting an offset from the player, and that's it. If we change it to world space and start strafing, you'll notice I actually strafe side to side now. There's still a little bit of that circular movement, but it's a lot better than it used to be. But we're still staring at the character's feet. So I changed this under this section that says orbits. There's a binding mode value. It originally said lock to target. Sorry, no, it said simple follow with world up. I changed it to say world space. So there's no following behavior at all now. And the nice thing about this is when we have this turned on, we can now adjust our damping in different directions. If we want to have the camera ease and follow the player or not, we can also adjust this tracked object offset. So what I'm going to do, once I've got it set to world, is I'm going to change this tracked object offset Y value to move it up. So we're circling the character from higher up on their body. So we normally don't need to look at the character's feet for this kind of game. So I'm going to change the tracked object offset on all these to 1. So to change all 3 rigs, we need to go to the top rig and change the value, go to the middle rig, change the value, and then go to the bottom rig and change the value. Now that feels a lot better. Now, depending on how you want the camera to feel, there's still quite a bit of easing going on. When we look at each of these rigs again, above the tracked object offset, we have these damping values, which is similar to what we used before. What I kind of like to do for this is change the X and Z damping. So when I move forwards and back and left and right, the camera moves quicker to keep up with my player. But I'm going to leave the Y damping where it is, so when I jump up and down, there's some easing there. It's not just locked to my character. So I'm going to change the X damping to 0.1. and the Z damping to 0.1. And I'm going to do that for all 3 rigs. Now the camera motion is quite a bit more snappy. I still like to leave a little bit of damping or else it feels kind of jittery. That feels pretty good. Okay, now there's a lot of other stuff we can play with on our camera here. A lot of games that are third person, if they are like platforming games, they might have the character in the center like Mario. If you're doing a third person shooter or more like action game like God of War, kind of depends on the mode you're in, but most of the time the character's kind of to one side or the other. Now, I personally absolutely hate it when games switch which shoulder you're looking over. Horizon Zero Dawn does a bit of that. But we can add a special little extension to our camera to move the camera left and right. Now, the reason why we do this is to avoid some of the weirdness we'd end up with if we just tried to offset the camera around the player. Good example here is like, okay, I want to move the player to the left of my screen, so I'm kind of looking over the right-hand shoulder. Easy. On my middle rig, for instance, I can change the X value to be 1. Cool, it's to the side. Except now when I rotate, I'm looking to a position right of the player. The player's not to the right of my, or not to the left of my screen. So this way it looks fine, but when I turn around, it does this. And all sorts of other weirdness we don't want. So they have a special extension that takes care of this for us. If we scroll down, there's a section here that says extensions. It says add extension. We can click the drop down. There's a whole bunch of stuff here. The one we're going to use is called a Cinemachine camera offset. It's the one at the very, very top. So the camera offset is interesting in that we can choose when it adjusts our camera. We're going to leave it set to the default of aim. And the nice thing about this is we're doing this after we do all of our aiming stuff, but before we do things like adding noise and stuff to our camera. But when we go and add 1 to the X value, it's actually moving the position relative to the camera rather than relative to the character. So now as I rotate my camera around, my character's always to the side. So to add the extension, just to restart, down at the very bottom where it says add extension, click on the select button and select the very top option, the Cinemachine camera offset. And then I just changed the X value to 1. Yeah. Yeah.
Is there any reason when you're walking, you try to turn off? It's almost like a stutter.
There might be actually in this version of my movement, I actually fixed a bug a couple weeks ago after we downloaded this project that improved some of the smoothing. Let me try something really quick and figure out if it's going to fix it. Give me 1 second. See if that improved it. Yeah, I think that helped. If you're having a little bit of stutter when the character rotates, you can see mine's quite a bit smoother now. If you're having some issues there, I fixed a bug in my movements a couple weeks ago. If you go to Window and go down to Package Manager, you can update this package here, this character movement. Right now you're on 2.4.0. If you click on the update button, it goes to 2.4.1 and it's going to smooth that issue out. I was doing the rotation step in kind of a weird spot in code, which was causing a little bit of a stutter. They have a little bit of stuff set up. We're going to talk about this more next term in the code stream. What they recommend using, which I really don't like, is they have a special component called I think it's just the character controller. It's kind of weird. It forces you to kind of write all the physics for your character from scratch, and it doesn't interact with physics systems all that well. The nice thing about it is it's very configurable, but you kind of have to do a lot on your own. I prefer to let things interact with the physics system better. So I write mine from scratch using the rigid body physics system. So when I have things like knocking the player around or launching it or other stuff, that all interacts the way you think it would. So I've built the system on top of it. In the code stream, we're going to write basically all these scripts from scratch. That feels a bit better. Yeah. Yeah. You might be rotating a little bit slow. On the character movement 3D component, you can turn up the turn speed a bit, maybe to 20. Might make them feel a little bit more snappy. Yeah. But there we go. Cool. Okay, so another issue with our camera is that when I go up against a wall, we get this behavior. Not really what we're looking for. Now, there is a component in Cinemachine that can help with this. But there are a few different strategies for dealing with this. So first, kind of most obvious thing is to add some sort of component that will move our camera forward so it doesn't go through geometry. Another option is to have something set up, usually using a mix of code and shaders, to basically remove part of the wall so you can see through it. A lot of games do this. There's a few different ways of styling it. You might have noticed playing things like Baldur's Gate 3. Anyone's been playing that, or the old Divinity Original Sin. I'll find a screenshot of this.
Pierce, is there a spring arm in this?
Not quite the spring arm, but it's something similar. Let's try to find an example, and apparently I can't. Oh yeah, here we go. Good example is this from Divinity Original Sin. They have a system set up, so they basically just carve out geometry that's in between the camera and the player, so they don't have to move the camera at all. You can just see through it. It's kind of a weird effect. They actually add this like noise to the edge, so it looks less mechanical, but ends up looking, honestly, kind of strange. There's a lot of different ways of doing this. You can see examples like this. Yeah. Yeah, so this is sort of a mix of code and shader. Some games will just straight up hide objects in front. I was actually looking at this with another student earlier. So if you look at something like Diablo 4 is a good example of kind of two things I want to show. So they have a system in place where when we get further in this dungeon, they go up to a door. Here we go, right here. So as they go through this door, you can see there's this whole section of the level in the way. Basically just fades out and disappears. So again, that's sort of a mix of code and shader, just removing that object from being in the way. Yeah, they're doing that quite a bit. So that's one option. But the thing I like to point out before you get to either of these steps, either adding collision for your camera or adding in systems to like hide geometry in the world, the best strategy is something else they do in Diablo 4 a lot, which is just don't put a wall there. Just stop doing that. A lot of students do that. They'll do like, oh, my character's supposed to be in a house and I have an isometric camera. So I've modeled the whole roof and the chimney and all the walls and all this crap in the way of the character. And it's like, why did you do that? Like at a certain point, we're making video games and people understand that. Even if you style it right, it looks pretty good. So a good example here in Diablo, if you can stop messing with this UI and actually run around, they've set their levels up deliberately so things aren't in the way of the camera. you can see a lot of the walls in front of the player. So they've got a wall here, but down on this side, they have some water, and it just sort of drops off. So they're still setting up barriers inside their world that look good, they fit in, they make sense, but they're not in the way of the camera. And then what few objects they have that might get in the way, they do that little fading trick to hide them. So the best strategy at the start is honestly just don't put stuff in the way of the camera. From there, you can come up with some different solutions. I've even seen some games with dungeons like this where they have the walls on this side will be normal. The walls close to the camera, if you actually look at them, they're at like a 45-degree angle. So you're kind of looking down the side of them and they don't get in the way of the player. You really stop and stare at them, they look weird. Most of the time when you're just running through killing stuff, it looks awesome and nothing's in the way of the camera. But a lot of this stuff is really just don't overthink it. Now, if we're making something like a third-person game like this and we can't really get around the fact that something's going to get in the way, Cinemachine does have a special extension for this. So if we go down, again, on the Cinemachine component to the bottom, go to the extension section, go to Add Extension, and look for the Cinemachine Collider. So the collider is set up, so it's basically going to detect where the player, where the camera is going to hit stuff circling around the player, and then move it accordingly. It has a few different strategies. The default one is preserve camera height. So if you hit the wall, it's going to pull the camera in, but keep the same height in the world. You can also play around with stuff like pull the camera forward, so it kind of zooms in. There's preserve camera distance, so it sort of pushes up against the wall and moves the camera, but keeps the same distance away. There's a lot of different tuning values here. The effect here is if I go against the wall, I get this. Now, if we want something, right now our camera is very far away from the player. We could go and set up something a little bit more like Horizon Zero Dawn or God of War, where we're zoomed in a little bit closer to the character. Or Last of Us. Wow, Sony's really got a formula for their popular games. We can go in and play around with this radius value that's on the rigs. So our top, middle, and bottom rig all have a slightly different radius, which is how far away the camera is on that point. Now, we'll probably have to adjust a little bit of it all over the place, but we can lower these radius values down to move in closer to our player. So if I take a look at my middle rig here, right now I'm this far away, I can start dropping the radius down, get closer, but you notice the height gets a little bit weird too. So I can also adjust the height. In this setup, we might have to adjust the on the aim, the tracked object offset as well. So I'm going to play around with a little bit of both of these. So right now I just changed these three values. So on my middle rig, my height is at 1.8, so it's basically like just shy of 6 feet tall. My radius is 1.25. And then on my tracked object offset, I have the Y value set at 1.6. So my middle rig looks something like this during gameplay. I'll have to adjust the other rigs so they look similar, because right now they're going to do some wild stuff. The character is also quite a bit to the left of my screen right now. If I want to bring it in a little bit on that offset component, I can lower that down. That looks a little bit better. Then we can play around with our other settings. So I like to click on these different rig buttons so I see the exact view I'm going to get. So my middle rig is what I'm looking basically straight forward. Then we can play around with our top and our bottom rig as well. Now, one trick some games do to make it look even further down, you can actually change the offset down here, but I think these settings will probably look okay. Not feeling too bad. You spend a lot of time tuning this stuff and kind of refining it.
Must be your soul.
Oh, another trick for sort of occlusion stuff that a lot of games do is the other effect they do is when you bump into a wall like this and your character gets too close to the camera, they'll often fade your character out so you see through them completely, so you just see the world, so you don't have like super zoomed in like textures that aren't really meant for that distance like stuck in front of the camera. That's not bad. I think my field of view might be a bit high. So we can also play around with that, combined with their other values. A lot of like small tuning opportunities here. One thing that's actually really handy is I recommend students, it doesn't matter what they're working on, like art, level design, code, whatever, is to get reference for things. So if you're trying to mimic a game, and even if you're not trying to end up as an exact copy of a game, it's not a bad idea if you're like trying to copy like God of War.
Camera just like
I can show you. Go to gameplay. Great to get like a gameplay shot. Take a look at it, compare it to your game. Even if you want, save the image and just drag it into like overlay it on your screen at like half opacity and kind of play around with the different angles and just see how your character lines up with whatever your reference is. So we can see in different modes, his camera kind of changes when he's like walking around normally with his weapon out, a little bit zoomed out. I think when you start aiming your Leviathan axe, it zooms in a bit. Then they have like a million different quick time events and stuff in the combat in this. So there's a lot of different cameras moving around doing different things. And then yes, as you brought up, they have a pretty cool camera system where it never does like a fade to black. It's always moving the camera around to the next part and sort of continuing on with the gameplay. It looks really cool. I've heard the developers said it was miserable setting all that up. It's nice sometimes just to be able to cut and just have a camera start somewhere else. I know they released a really good reel of like bloopers of their whole animation and camera system screwing up. Yeah, it's entertaining. So for something like that, Cinemachine actually does a really good job of that. So we can have different cameras set up for different things and kind of transition in from different states to enter into gameplay. I'm trying to think of something we can set up quick here. We only have a few minutes, but we probably could run through this a little bit quickly. I was hoping to get into it more today. We might have to have a extra class later on at some point to cover it, but Unity has some cinematic tools that are available. One of them is called Timeline. It basically allows you to sync up camera changes, audio, animations, VFX, all sorts of different stuff, and kind of fine tune them to do things like cinematics or even in-game like QuickTime events and other stuff like that. If we wanted to have something in place, so we'd have our camera like move in and then hit the player and we'd start playing from that point, we could do that using Timeline. So if we want to set this up really quick, we could probably get something very simple going. We can go into our scene and let's go create a new object. I'm going to right click and go create empty. And I'm going to call this game object intro cinematic, which I spelled wrong, cinematic. From here, we're going to go open up a special window that can control the timelines and sequences in our game. So we're going to go up to Window and go down to Sequencing to open up the timeline window. And I want to be able to see my game at the same time I see the timeline. So I'm going to move this around a little bit. I'm going to grab my timeline window. So again, remember we went to Window, Sequencing, and Timeline. And I'm going to drag my timeline window, and I'm actually going to dock it down here beside the project and console. So this kind of fits well. Now you notice when we have an empty game object selected, like the intro cinematic, we can go click the Create button. And it's going to go and add a few components and set some things up for us to create our first little cinematic here. So with intro cinematic selected, I'm going to click on this create button. And it's going to ask us where we're going to save this thing. Right now in our assets, we're inside like the scenes folder. We can kind of put this anywhere, but in the sake of keeping organized, I'm going to click on the little assets button here to move up one folder into our root assets. And I'll make a folder called Cinematics. So I just created a folder inside Assets called Cinematics, and I'll save it in here. So that does a couple things. It creates on our game object a component called the playable director, which is the thing that sort of plays the cinematic. The cinematic information, all of its data, is actually stored in a little file called the intro cinematic timeline. And we can edit all that stuff down here. So there are actually a bunch of different options for things we can control through the timeline. There's actually a couple teams using it downstairs in really weird ways. One team is doing like a rhythm game type thing. If anyone's played it, the Boxall game, they're actually doing all their rhythm game stuff through the timeline. So they've hooked up all their events and everything right on this graph, and they can like visually map it out. There's a bunch of different things we can affect. We can affect cameras, audio, VFX. You can even just send code signals to have things respond. But there's a specific thing we can set up to work with Cinemachine. So if we right click in the left-hand side of our timeline window here, there's a bunch of different tracks we can create. I'm going to create one called the Cinemachine track. And this allows us to drag different Cinemachine cameras onto the track to control when they turn on and off. And even though we're turning them on and off, they still adhere to that kind of interpolation system we looked at. So they'll sort of smoothly move between different cameras. So we can have one moving around on a track, turn off and switch to our gameplay camera, and they'll kind of match up and move into each other properly. Now, what it requires here is access. Remember that control component we talked about, the Cinemachine brain that's on our main camera? It needs access to that. So what I'm going to do to plug it in is in our camera section, I'm going to drag my main camera onto the field here where it says Cinemachine brain. So I'm just going to drag my camera right down on here. From there, the rest of the controls are pretty simple. We can drag different cameras onto our timeline, and as the timeline plays, it's going to turn those cameras on and off. So a good example, in my scene, I'm going to say we're just going to have like a, do sort of like a intro shot showing the level, and that camera is going to transition into my player, and I can start running around. So I'm going to move my camera and my scene view up here to get the shot I want. Then we're just going to create another virtual camera that's going to do nothing. It's just going to exist in the scene. But we're going to turn it on and off using our timeline. So inside our hierarchy, I'm going to right click and go Cinemachine to create another virtual camera. Now, I mentioned this hotkey before. Does anyone remember the hotkey to move something in your scene to where your camera is? Control Shift F. So if we have our virtual camera selected and I have my scene view camera where I want it, I can hit Control Shift F and it's going to move my camera right there. So this camera is not going to do anything. It's just going to sit completely motionless, but it's going to be the shot we want at the intro to our little scene here. What I'm going to do next is I'm going to click on my intro cinematic again, and we can take a look at our Cinemachine track. So we can drag whatever cameras we want on here. I can drag my new virtual camera that I created from the hierarchy directly onto my graph just by grabbing it and dragging it and dropping it on the track on the right-hand side here. Now, one thing I don't like about the default settings for the timeline is I look at 300 and I'm like, okay, 300 is probably frames. How many frames per second does the timeline run at? I can't remember. I'm not an animator. So we can actually switch this over to be in seconds, which makes a lot more sense to me. In the top right of this menu is a little gear that says options. If we click on that, we can switch it from frames over to seconds, which in my mind makes a lot more sense. I can time exactly when I want the cutscene to time things. Yes. It's usually just whatever the game's running at. Yeah. Not that I know of. You probably could. Might be interesting. I know some games with bad optimization have claimed they're more cinematic because of the frame rate, but that's about it. So I'll switch this over to seconds. So I can see now, okay, so it was saying 60 FPS, or after 5 seconds, that's 300 frames. That's probably too long of a shot. So we can actually grab the end of this and drag it around to be as long as we want. So I'm going to drag this down to 2 seconds.
How did we create the points again?
The which?
The points in the timeline?
Like this thing?
Yeah.
So I just dragged this virtual camera to do it again. Drag it right out of the hierarchy, right onto this track. Yeah. So I shrunk that down to 2 seconds, and then we can drag our free look camera on here to enable it afterwards. And the length of this one doesn't really matter. It should turn it on, and then we should stay with that camera enabled. Now, one cool thing about Timeline is you can actually preview this stuff before the game's even running. In the top left of the timeline view, if we click on the play button, it's going to scrub through. And we can see one camera turning off and the other one turning on again. Now, again, in edit mode, it doesn't show like the nice transition, but we can see them enabling and disabling. By default, these timelines will run automatically. So if I just hit play and play my game, I'm gonna have 2 seconds of that shot, and then, oh, it flipped over really hard. Let's see if we can go and blend these together a bit better. Where is that? I know there's an option. Oh, that's right. I'm not sure if there's a nice hotkey for this. Oh, there is. We can use Shift. Cool. So if we want these to blend together, right now they're like hard cuts. It's useful if you're doing like a security camera or like another point of view. If you wanted to nicely transition from one to the other, instead of adjusting the duration of these just by dragging the edges, I can hold Shift and grab the edge and drag to blend them together. So it does that. You can see how the cams are kind of overlapping. So hold shift and grab the transition line in between the two of them. And you can make the transition longer or shorter all the way down to 0, so it's a hard cut. If I turn it up to like 1 second, we'll get a pretty long transition from one camera to the other. Yeah. Reset it. So I've got both cameras dragged onto my timeline. And there's like a line in between the two where one stops and one starts. If I hold shift and then click and drag the transition between the two of them, it creates a blend. Yeah. You can also manually set it here by adjusting the ease out or ease in duration. But this is kind of easier. Oops. So we can create our little transition that way. Now, we're just doing a static camera to a gameplay camera. We could have that camera moving around through like a cinematic or on a track or something like that. You'll also notice it does introduce some bugs. Probably not something we want, where if we hit play and start running around, we can be running around during our cutscene, which is probably not something we want. So we can also use timeline to send a message to the player saying, hey, you can't move during this. You'll stand there and be motionless. Or some games will even basically just remove the playable character and they'll bring in a cinematic specific one. I've seen this a lot in, again, a lot of the Sony games. They swap the characters in and out depending on how close the camera is going to get. So they go into like a cinematic mode. They swap the character with a higher quality one for those nice like close in shots. So if you're running around behind, like staring at the back of their head most of the time, you don't really need like all the nice rig with the facial animations and all that kind of stuff going. What, sorry? If I just hit play and play my game, yeah, it'll kick in automatically. Sorry, like base it on input? Yeah, you totally can, yeah. Even that can be a little bit easier. Just by turning on or off certain virtual cameras or changing their priority will cause them the camera to move around as well. Yeah. So we didn't get enough time to go through a lot of the stuff in timeline. You can control animation in the scene, so you can like open and close doors and do all sorts of other stuff as part of the timeline system. If your class is interested in that, or maybe team project, I can cover a little bit of that in one of our lecture classes.
Yes, please.
If you want to get really fancy, you can even tie certain post-processing and stuff to certain cameras. So you can have like cinematic cameras that look more cinematic, and have depth of field and all that fancy stuff that kind of interferes with gameplay turned on. Then when you kick over to your gameplay camera, all that stuff turns off. Yeah.
In case you don't have time to do it,
yeah.
Do you have videos from teaching this previously that we can watch?
I do. I'll try and dig it up. Yeah. Okay, it's 3:59. We'll wrap things up for today. As promised, next week we'll do some VFX stuff and we'll light Chris on fire. And we'll see how far we get playing around with VFX. Oh, and sorry, I keep forgetting. Should follow my own advice here. We can go and commit everything we've done in class today. If we open up Fork, we can go through our usual process of staging and committing all of our changes. So in Fork, remember the steps we want to go through. We want to open up Fork. Make sure we're on the right project. You might have your Unreal projects open as well. Make sure you pay attention which projects you have open. I've messed this up myself. There was one really bad one. I was tinkering around with a student final project and made some changes to their scene and messed with their lighting and changed a whole bunch of stuff. Then closed it, worked on another project of my own. And when I finished, without paying attention, went over to my version control, committed, staged everything, pushed it, and left for the day. And I got a message like on my way home from the students were like, hey, you made some changes to our project? And I was like, oh no. So you don't want to be in that spot. So make sure you're paying attention to which project you're actually committing changes to. So, yeah. In my defense, my lighting looked better. They actually ended up they didn't use exactly what I did, but they reworked some of their lighting using some of the stuff I did. Yeah. So we'll go to the local changes tab here, and we'll commit all of our changes by clicking the double down arrow right here to stage all. Then we can give a commit subject, and we'll go at added example gameplay cameras and simple intro cinematic shot. Yep. Oh, so Fork's a little bit weird in that it divides these up. Most clients and Git under the hood doesn't really have the idea of like, what do they call it? They call it subject and description. Most of the time it's just like a single string. So it doesn't really matter where you put stuff. And I think it always kind of looks the same on the other end. So I usually just put everything into the subject. There is, yeah. I think they're doing something weird there. Yeah, you can see the -12 here. Yeah, it doesn't really matter as long as that text is in there so you can see it on your graph later. So go commit. Then finally, if I want everything backed up, I can go and push. Oh my God, I literally did that. As I was explaining, make sure you pay attention to where you are. I committed that in the wrong project. I can undo that. Here we go.
It was to give an example.
Yeah.
Oh yeah,
Yeah.
show us how to.
Oh, I was straight up in the wrong project. That's why I did that. Whew. Whoops. Okay, yeah. So if you're dumb like me and you ever commit something like that, you want to nuke it, there's actually a special command you can run. If you click on the, so this is only something you can do through the console. This is the magic I done goofed up and need to reset it.
My friend wants something.
So you can go type in, and I actually have this listed on Discord as well. If you go to the Git documentation, I have the, if Discord's going to load. Wow. Okay, this command right here, this git reset hard origin / develop. Now, I'm on a specific branch, so what I'm going to type here is git reset. Yeah, here we go. I'm going to go git reset hard origin / and the branch I actually happen to be called is on right now. It's called feature helmet cam. It's going to be feature / helmet cam. And that basically resets everything I've done, including commits, back to wherever it is on the remote. So it basically says, whatever I've got here, I want to be exactly equal to what's on GitHub. So it's pretty useful. If you accidentally make a wrong commit, just keep in mind, this nukes all the work you've done, which might not be a good option. If you're ever in a spot where you're like, okay, I want to keep some of this, come talk to me and I can kind of walk you through pulling out what you need. Yeah, basically in whatever repository you're currently in. Yeah, whatever you have done locally that you haven't pushed yet. If something's been pushed, it's fine. But any changes since the last time you pushed get reset.
Why wouldn't you just copy your folder, package it?
You could do that. Yeah, that's an option. Normally I do this when it's like I've done something really dumb and I need to nuke all of it and I don't want to keep any of it. That's when I do this. Sorry, you saying?
It says tell us to like playtest the thing.
Yes, we'll go over creating builds in Team Project next term. Yeah. Yeah. It's not really important until then.
Don't you recommend us like playtesting in our build strat in engine to see if it crashes?
Yes, but you don't really have games yet, so yeah. Okay, so we'll wrap things up for today. As I mentioned, next week we'll do VFX. I'll get a copy of the recording from today uploaded to YouTube and added to your playlist.